Welcome, everyone. My name is Bruce Belzowski. I'm the Managing Director of the Automotive Futures Group here in Ann Arbor, Michigan. I'm retired from the University of Michigan Transportation Research Institute, and I'm here to welcome you and thank you for all for attending our new role of government in the U.S. automotive industry. We started this conference back in 2010 as well, and one of our speakers at that time was John Dingell. And we now have his wife speaking with us today. So we're looking forward to hearing her comments as well as everyone else's. We want to thank all our speakers who are with us today, who are going to give us their insights and how they see the government, the new administration changing or keeping things the same in terms of how they relate to the U.S. automotive industry. I want to start off my presentation with a intro to our group and to what we're doing here, and also an intro to the conference. As I said, I'm the Managing Director of the Automotive Futures Group. I retired from the University of Michigan. Our funding for our program comes from our affiliate program, which has supporting members and research partners. And our research focuses on the globalization of the industry, advanced powertrains, and intelligent transportation systems. And we also get some of our funding from our 5 annual conferences. But we would not be able to survive in today's world without our affiliate members. This is our list of affiliate members. And one of the things that has changed since the last time was the introduction, inclusion of Mazda North America, but also the introduction of Amstead Automotive, which has merged, used to be Means Industries, which merged with a couple of other companies to become Amstead Automotive, and we continue to welcome them. From our research partners, they come from IT, OEMs, government and NGOs, as well as suppliers and consultants. Our research projects focus on powertrain strategies. We have a powertrain strategies for the 21st century projects that's been going on since 2007, 2008. We've been following the Chinese new energy vehicle and now the global new energy vehicles and electric vehicle project for the last 4 or 5 years. We're looking at new mobility, in particular from our conferences. We're looking at the effect of Tesla is having on the auto industry. We have a thing going on right now to a project that is, we're starting to do the analysis from a survey of what people thought about Tesla. And this is industry experts giving their feelings about this. And we also, as I said, have our global EV project. Globalization we look at, we'll talk a little bit in my presentation today. I'll be looking at a little bit from the European and Asian perspectives for the role of government. But we'll also look at that from our conferences. And finally, we have our third U of M automotive student survey, kind of looking at the attitudes of students about their future vehicle purchases. We'll be starting that this coming September. Our researchers made up primarily of student researchers and Kara Elkire, who's online on the YouTube video live stream today, watching things there. And these are the students that are from a variety of different areas within the university, giving us their support. One of the things that we've instituted during the pandemic, we've really put a focus on our LinkedIn page, trying to gain more people to follow the information that we're going to be giving out, that we have been giving out. Usually we post about 2 to 3 times a week with information about our conferences, about our speakers, about our research, and anything else that we think is important about what's going on in the automotive industry. Our next conference is on July 14th, looking at powertrain strategies for the 21st century. This will be our 13th annual. We'll also follow that up, I think, on September 8th with our Future of Automotive IT conference. For conference logistics, we're looking at our presenters. Peter Fagee, Michael Hartrick, Debbie Dingle, William Charmley, and Gary Marchant is with us today. They'll be giving us their opinions about how they see the role of government changing or maybe staying the same in certain cases. We'll start out with Gary, then we'll have a Q&A with him, then go to Debbie, then go to Peter. Both have Q&As after their sessions. We'll go to a break, then we'll go to Bill, and with his Q&A, and Michael will get the last word in his Q&A. For post-conference attendees, registrants will get a link to the presentations. Our affiliates get that, as well as a document that summarizes reviews the highlights of the conference. The agenda, the speaker bios, registration lists, sponsorship opportunities, affiliate information, and upcoming events are all on our conference website. We put that in the email that we sent to you yesterday. That includes the live stream link for this conference. Audience questions we suggest and hope that audience gets a chance to participate. They can enter questions through the chat in the YouTube live stream, but we also sent in the link in the email that we sent you yesterday, with the live stream link, a link to ask questions through an anonymous form if you want to do that. One of the final things is that we like to focus on the conference feedback. If you see things that work or didn't work or that you enjoyed, we really appreciate any kind of feedback we can get. We actually will, one of the things my students has taught me, that the best way to get people to do this is to actually take about 3 minutes of time during the conference to actually have you fill out the feedback form, and we'll do that towards the end of the conference. Okay. As a setup for our speakers today, I want to talk a little bit about what we see happening in terms of from the U.S., European, and Asian perspectives in terms of policies and standards. For fuel economy policy, in 2020, NHTSA and EPA finalized and revised the standards for model year 21 and 20 to 26. As part of the rule, EPA revoked California's authority to establish GHG emission standards, and California-led coalition of states has sued to challenge the rule. Bill Charmley from EPA will give us some updates, if he has any, on where that stands. New standards and the new standards that are now in a place based on the previous administration was fuel economy improvements of 1.5% annually, compared to the 5% annual improvements that were required under the Obama era rule. And what has happened from the manufacturers? Well, Stellantis, Toyota, and other major manufacturers have dropped out of the legal battle between the federal government and California over the state's right to set its own standards. General Motors, that was part of that group, has also dropped out of that lawsuit. Ford, Honda, and Volkswagen were never part of the suit, and they had been working with California and actually came up with an agreement of 3.7% increases per year on fuel economy, and we'll be interested to hear if any one of our speakers have any insight on where that is right now. EPA's direction under the Biden administration, they're now rewriting the previous administration rules that relaxed limits on greenhouse gases from vehicles. They're on track to propose by the end of July new limits on the emission of greenhouse gases. And the official signal, the EPA is not really going to be focusing on reducing these numbers. In NHTSA's role, it says NHTSA will continue to exercise its regulatory authority over the electric vehicles, as well as all kinds of types of alternative fueled vehicles for fuel economy, but also we're looking at NHTSA's primary role as a safety arbiter, trying to focus on where we're heading in terms of safety, and in particularly for automated vehicles. So for automated vehicles, they're looking at modifying some of the codes that they have for automakers that restrict certain kinds of ways that the manufacturers design vehicles. And they also said that every seat would be a passenger seat for self-driving vehicles. These are things that they're working on. So that is really good news for the Amazons of the world who want to have driverless delivery pods, because those vehicles will not have to comply to occupant protection standards because there are no people in those vehicles. So it'll be interesting to see how that is going to play out. So one of the focus in that case is on the promotion of collaboration and transparency with all the stakeholders and partners that are looking at in developing automated vehicles, modernizing of the regulatory environment, and preparing the transportation system for the introduction of automated vehicles. From an international perspective, we look at from the European side, they've done work on diesels, light duty, as well as gasoline engine light duty vehicles, basically reducing the emissions that they require and going out to 2030. And they're doing this in such a way that we're seeing, and we saw this in 2020, that the Europeans actually sold more what we would call new energy vehicles, fuel cells, pure electrics, and plug-in hybrid vehicles, sold more of those vehicles in 2020 than the Chinese, who had been the leaders for a number of years. They was very similar, very close in terms of the numbers of vehicles sold, but still the Europeans sold more, primarily because of the regulatory environment that focused on their requirement for lowering their emissions. And also tied to that are some very strict penalties that come out of that. So they had three primary goals: setting up a single air pollutant emission standard for cars, vans, trucks, and buses, and simplifying the existing emissions test, while keeping a focus on real world testing, something that we'll be introducing in the U.S. and again, Bill Charmley will get us a little update on that. Also, stricter emission limits on air pollutants and including real-world emissions monitoring. Again, this is really tricky here because they're talking about monitoring over the lifetime of a vehicle, which is very different from only looking at vehicles new vehicles that are being put on the road. Also, when they look at the issues related to the EU in September of last year, they approved a framework that starts to apply across the EU and raises the quality level and the independence of vehicle and type approval and testing, increases the checks on vehicles. So this is something that the Europeans are doing, and notice on the last bullet there, where there's a 30,000 euro per vehicle fine for not meeting the legislative regulations for your company. So this is something that is forcing the industry to adjust and to start. And now on a monthly basis, when you look at sales of European vehicles, a lot of plug-in hybrid vehicles as well as electric vehicles, probably equal amounts. But this is something that manufacturers are doing to make sure that they meet their regulatory goals. When you look at Asia, China started in July 1st of 2020. They're using China 6, very similar to Euro 6 emission standards, not allowing vehicles with the China 5 standard to be produced or imported into China. And starting this year, all light-duty vehicles manufactured and imported should comply with a particular particulate number. In Japan, most recently, they've been looking at raising the 2030 greenhouse gas emissions reduction target to at least 40%, with a 40% cut from 2013 levels, from the 26% now. The Japanese Environment Ministry is proposing a more ambitious target of reducing emissions by 45%. The Industry Ministry is pushing for a more conservative goal of 35%. When you look at the issues related to advanced safety technologies and automated vehicles and autonomous vehicles, 50 countries have now signed on to as members to agree on common regulations for vehicles that take over some driving functions. This most recently, it has to do with lane keeping systems, as well as speed limits at which time when these technologies kick in, and also that manufacturers are to introduce driver availability recognition systems, which monitor the driver's capability to take back control of the vehicle through eye spotting, eye blinking, and closure technology. This is something that we're just looking at in the U.S. I know from the researchers that I worked with at the U of M Transportation Research Institute, they said it's very difficult for drivers who are not paying attention to come back, who have been told that they do not have to pay attention, to come back and get involved in driving again. And sometimes it's a very difficult challenge for them. So this is something I think that's going to be looked at in the U.S. as well. And finally, from the German side, that the Germans were originally looking at mainly at passenger cars controlled by automated systems, and they had not really set up fully autonomous vehicle driving regulations. But now that they have published a legislative proposal for the approval of completely driverless vehicles, the Autonomous Driving Act. So this is a kind of an overview and a setup for our discussion today in terms of where we are in terms of regulatory. Now we didn't talk much about incentives, because that is something that also plays a role in what's going on in the industry. And this is something that our next speaker, Gary Marchant, from Regents Professor of Law and Director of the Center for Law, Science, and Innovation at Arizona State University. Gary's research interests include legal aspects of genomics and personalized medicine, the use of genetic information in environmental regulation, risk and the precautionary principle, and the governance of emergency technologies, such as nanotechnology, neuroscience, biotechnology, and artificial intelligence. Prior to joining ASU in 1999, he was a partner at Washington, D.C. office of Kirkland & Ellis, where his practice focused on environmental and administrative law. He's a frequent speaker and lecturer on law and science. He's been author of over 150 articles and book chapters, and he's served on 5 previous National Academy of Sciences committees. Gary is going to be talking to us today about his work on the assessment of technologies for improving light-duty vehicle fuel economy from 2025 to 2030 for the National Academies of Sciences, Engineering, and Medicine. Thank you, Gary. Take it away.
Thanks, Bruce, and I'm delighted to be here today to talk to you about this new study that just came out last week, so it's very timely. So our report was published last week, and so we're just a week into it. So this is a study that's commissioned by the Department of Transportation and mandated by Congress under the 2007 Act. We were asked to look at the cost, fuel economy, benefits, and implementation timing of light-duty vehicle efficiency technologies in the 2025 to 2035 period. So, we didn't look at before 2025 and we didn't look after 2035. We just looked at this 10-year period, which I think we all expect to be a really exciting and important time in the development of light duty vehicles. So the technologies we were specifically asked to address included electric, hybrid, internal combustion engines, fuel cells, non-powertrain and connected autonomous vehicle technologies. We were also asked to address consumer responses, regulatory consideration, and the impact of shifting transportation choices and business models on technologies and vehicle use. So we did all that. It's a report was again published last week. It's about a 400-page report. It goes into great detail on a lot of different of these subjects in a lot more detail than I can cover today. I'm just going to give you sort of the big picture, focusing on the theme of today's meeting. But this is available online for free at the National Academy of Sciences site at this link here you see there, nas.edu/fuel economy. We were really advantaged by having a tremendous amount of input in our study. It's about a 3-year project. We had a number of public hearings where we had testimony from a wide range of people from the government, from industry, and from the NGO sector and academia. Particularly as COVID hit, we went to some more specialized topics for online webinars that were open to as many people wanted to attend for free. And those sort of went into depth on some specific issues we had questions about. We were also really helped by having site visits with a large number of OEMs and suppliers and battery manufacturers under NDAs. And so we're not allowed to talk about that specific information, but getting that background from the various industry partners was extremely helpful for us to understand where these technologies are going in the 2025 to 35 period. And we're very grateful for that information that was shared so generously by so many people. Here's our committee. It's a very broad group of people from a really nice diversity, as well as a tremendous amount of expertise from industry backgrounds, from NGOs, and from academia in a number of different fields. So the big picture, you're all probably familiar with that. Even though the CAFE program has now been in effect for over 40 years, the transportation sector is still the largest contributor of greenhouse gas emissions and the second largest energy consuming sector in the US economy. So not great news, but the good news is that the new vehicle technologies that are becoming feasible and cost effective in this period 2025 to 35 are going to enable major improvements in fuel economy and greenhouse gas emissions from light duty vehicles. And what was perhaps most important and exciting to us is everybody we spoke to was sort of converging on this idea that this is now a problem that could possibly be solved, that we may be able to move beyond this being an issue for light duty vehicles in the next couple decades. Not immediately, obviously, but the technologies are now coming on stream online that are really going to enable a major change in how vehicles are powered and also the environmental consequences of those power choices. This will involve an unprecedented amount of technological change in the period we studied, 2020 to 5 to 35, affecting everybody in the transportation sector, not only the OEMs and the suppliers, but dealers, insurers, fleet owners, and of course, consumers. And so part of the management of this transition will be helping all those different sectors and stakeholders deal with these transactions and disruptions as we go to really a new type of vehicle for the first time in 100 years as our predominant form of light duty vehicle cars. So some of the key findings were on these specific technologies. I'm not going to go through these really in any detail today. These slides will be made available. And again, the whole report is available online. But we looked at internal combustion vehicles and have an extensive chapter on that. There is some room for a little bit of additional improvement. Probably, though, a lot of the manufacturers are going to flip over to using hybrids in combination with the ICE engine, just because that's going to be able to get better performance and better fuel efficiency at a cheaper cost and continuing to work on the ICEs alone. Battery electric vehicles will be a big deal in the 2025 to 2035 time period as the cost and the range and so on of those continue to improve. Fuel cell vehicles are also a viable option. One of the things we found in talking to vehicle manufacturers, again under NDAs, is they have different plans for how to get to where they want to get to. They sort of had a convergence on where they want to get to of a zero emission fleet, but how they get there, they had different plans. And I think that's fine. And so we want to enable all those different strategies and basically let the marketplace and the technologies try to prove themselves out. And fuel cell vehicles were an important option for some manufacturers, not necessarily all, just like battery electric vehicles were for others. And different companies had different priorities in terms of how much they were going to go, for example, to hybrids as a stepping stone to these zero emission vehicles, or just skip straight to the battery or the fuel cell vehicle. So there's quite a diversity of strategies. You can probably get a sense of that from just the public statements of a lot of the companies, but they're all sort of focused on getting this issue behind them, of getting the emissions problem solved, which is now for the first time a real possibility. There's additional improvements that can be made in things like mass reduction in tires and aerodynamics. Connected and autonomous vehicle technology would be another major development in this time period. That's going to be driven primarily by safety considerations, but the implications for environmental and fuel economy and fuel use and so on could really go either way, depending on some of the assumptions from both the federal and local regulation are going to be critical in terms of how these vehicles are actually used will affect their environmental performance. And then another topic that was raised a lot, sort of late in our process by some of the manufacturers, is the option of going to low carbon or zero carbon net synthetic fuels. And that's, again, another possibility on the horizon that may be considered in this 2025 to 35 time period. In addition to the technology, so we also focused a lot on some of the other sort of social factors and policy factors. One is, again, the consumer barriers that obviously cost is a big issue to go to things like fuel cell and battery electric vehicles, but we do think those issues will basically come down as these alternative powertrains become cost comparable to the internal combustion engine, probably around the 2030 period. If not before. So cost is not going to be such a big factor that will help people adjust to this shift. But there still is this consumer sort of psychological barrier to new types of vehicles. And we've seen this over history with every type of technology you can think of, that people are reluctant to change the way they do things. And so this does involve quite a significant paradigm change in how you power your vehicle, how you fuel your vehicle. We think in the long run, consumers will like this, that it'll be easier for them if you can just plug in at home instead of having to go to a gas station, that if the performance of these vehicles are very good in terms of things like acceleration, lower repair costs, and maybe lower operating costs. So we think that once people get the hang of it, they'll be quite happy with this shift. But there may need to be some policy interventions to help them get over that psychological barrier. And again, we have a number of recommendations on that. I'll come back to them in a second. The off-cycle technology issues will be a big thing of how we demonstrate and how manufacturers demonstrate those and validate those. And then again, autonomous vehicle policy, again, with safety being the primary driver, but the question is, how can they be encouraged to have a better environmental performance as well as a safety improvement? We also have a discussion of the current approach of having separate standards for cars and trucks. There's been a lot of changes in the market as there's been a lot of convergence with things like crossover vehicles and so on. And we think that should also be studied as another possible area for change. So our key overall findings, though, is that ZEVs will play a major role in the 2025 to 35 period, whether they be fuel cell, electric, battery electric, or whatever. And we expect them to be basically the dominant new cars in the market by 2035. So these will go from just a small percentage of our new vehicle market to becoming probably the dominant cars in the next 15 years. And that's quite a major shift. We think there are some legal issues that need to be addressed. We do think both the CAFE program and the EPA program should continue. They've been working in dual harmony, and that we think that can continue. The CAFE program specific authorization for standards ends in 2030. The statute probably would allow NHTSA to continue to operate after that, but there's no specific guidance, so it might be a good time to update that. And as we'll talk about, the idea of bringing greenhouse gas emissions to have some role within the CAFE program, I think will be important as we go to vehicles with zero tailpipe emissions. The question of upstream emissions will become an important factor to consider for all types of vehicles, and CO2 will be the key currency for looking at that. We do think there's a real major roadblock, though, for NHTSA in terms of going forward, in that they're not allowed to consider dedicated alternative fuel vehicles in setting the standards. They can give credits for meeting the standards, but not for setting the standards. And up until now, when these vehicles, like electric or fuel cell vehicles, are such a small part of the fleet, it hasn't been a problem. But as these become the majority of the fleet, it means that the CAFE standards, if that provision stays in effect, which is an artifact of an earlier era, would completely block NHTSA from adopting more rigorous standards that are compatible with and consistent with the major domination of ZEV vehicles. They wouldn't be able to count them and use them to set the standard. And at that point, then, the EPA is not restrained that way. We think the EPA should then go forward on its own, and we'd lose that harmony between the two agencies, and that would be unfortunate. So I really do think that's a really important thing for Congress to look at. Can they should rescind that. Maybe you could reinterpret it from the agency perspective. And, over the long term, we think that we should be looking at the full fuel cycle of all types of vehicles, not just battery electric, not just fuel cells, but the entire fleet of vehicles, particularly as many of them go to zero tailpipe emissions, that we, to really understand their environmental impact, we want to look at the full fuel cycle. And there's a lot of tricky issues in how you actually do that, but that should be something that needs to be looked at over the next decade as we go towards this domination with zero emission vehicles. Again, just in terms of technologies, we think there'll be a lot of different advances, and we go into great detail on those in the report as well. As well as fuel cells, and infrastructures are going to be a big deal for both electric vehicles and fuel cell vehicles. Again, I'll just skip over these, and these are all available online in the interest of time. So, what I really want to focus on now is sort of the role of government as our committee saw it. We thought there's really important role for Congress to define long-term energy emission goals for both the CAFE and greenhouse gas programs, to allow industry to plan and prevent pursuit of dead-end technologies. Again, we found this strong consensus among the manufacturers that eventually we need to get to zero emission, and that they're dedicated to doing that. They're keen and excited to do that. To get this off their plate is a major problem associated with their products. When that happens is a question mark, and how they get there is sort of a question mark, and how much freedom and flexibility they have. So, things like the CAFE program can only set the standards for a 5-year period. And we think it's important sort of to provide a longer term objective that maybe Congress should be the appropriate body to do so that manufacturers can plan how they're going to get there. What will be their stepping stones? What technology should they invest in, given the market and their plans for the next few years, but also the longer term goal, and not to then get stranded with some technologies that aren't going to allow them to continue to move on where they need to get. And so again, we found sort of a lot of interest in that from manufacturers, of really wanting to know what's sort of expected of them and when, so that they can plan accordingly. And then NHTSA and EPA should adopt regulations to the extent they can, maybe if it's only in 5 years for NHTSA, that are towards that goal. Again, that we do think should be a goal, that all new light duty vehicles will have zero net greenhouse gas emissions by specific dates. That I think is a feasible goal, and it's a real, I think, change that we've gotten to that point, thanks to all the the good work in developing these technologies, that really is a feasible thing now in the next couple decades, that we can get to that really amazing place because of these new technologies. We do think, though, that the government needs to maintain technology neutrality, that because different manufacturers are working and investing in different technologies, that should be encouraged, as long as they're all working towards the same overall goal and they know what that goal is. And again, in order, as we go to more and more types of vehicles that don't have any tailpipe emissions, it's important to look at the full fuel cycle to incorporate upstream emissions. And again, CO2 is going to be the common metric, I think, to compare across different types of vehicle technologies to determine, how much credit you should get for different types of vehicles in the longer term. Again, we do think there's some problems on the supply side. Again, regulation can help with that, but also research and development investment from DOE and other agencies should continue, the work they've been doing in helping to develop things like improved batteries. Batteries are continuing to improve, and there's a lot more potential for them in the future. That's going to be very critical. We also think, things like improved test cycles and also to really understand real world operation. We don't really track the vehicles for their fuel economy and greenhouse gas emissions on the road. And we think that would be a useful set of data to start to get, not so much for compliance, but for evaluating the program and making sure it's achieving the goals that the agencies are intending. And then again, this whole question of whether there should be a single standard or separate standards and how that should go is also, I think, a question that should be addressed. But we really do think there needs to be also a lot of work on the demand side. Because we found a lot of frustration from manufacturers that they offer vehicles and no one wants to buy them because they seem unfamiliar to consumers. They're not comfortable with them, and even though everyone sort of senses that once they get used to them and once they have exposure to how they actually operate, they'll actually be very happy with these new technologies. And so getting over that hurdle, again, cost is part of the issue, but we think that's going to be addressed on its own because the cost of these alternate technologies are coming down pretty dramatically, and expect to achieve cost parity by about 2030. But the psychological barriers remain to be a major issue, and so we have a number of discussion and recommendations on things like continuing to give consumer price rebate, charging infrastructure, and maybe also other consumer incentives or public education. Ironically, we publicly issued our report at the exact moment that President Biden was announcing his infrastructure plan, which does include a number of these elements. And so we were happy to see that that was consistent with what the current president is recommending to go forward with on electric and zero emission vehicles. Again, another factor is international competitiveness. We do think that's really important. As Bruce was talking about, some other countries in Europe and Asia are going forward pretty dramatically with alternate powertrains, particularly ZEVs and fuel cell vehicles. And it's important for the US, both from an environmental and consumer perspective, but also from our industry perspective, to continue to be a leader in the automobile industry and to be at the forefront of these new technologies. And we do believe that strong US standards will help the US market then to remain, and technologies to remain competitive. And so it's important to encourage that. So that's about it. Just a high level summary. Again, the report is available to read and download free online. It's over 400 pages and goes into a lot more detail than I have here, but it's a really sort of exciting and interesting time. And we were very impressed and excited to see the essential consensus on where this sector is going in the next couple decades. And let me stop there and happy to answer any questions.
Very good. Thanks, Gary. But I have a few questions, Gary. One of the things that I think has been talked about recently is the e-fuels. How do e-fuels work?
So synthetic fuels, is that what you mean
Yeah,
by
yeah,
e-fuels?
yeah. Well,
Yeah, I mean,
you guys
so
are describing it.
yeah, so I mean, these would be low or even zero carbon fuels that I don't have a lot of expertise on it. We do have a chapter on that. That was not really within our initial plan of attack for our report, but because there was interest in this technology from some of the manufacturers and some other stakeholders who testified or submitted information to us, we did include them in there. And I think they're further behind time-wise than say electric or even fuel cell vehicles, but we don't want to discount them if they are capable of essentially getting a net zero emission vehicle. Again, this idea of encouraging technology neutrality. Of course, the big benefit of them is it would immediately affect the existing fleet as well as new vehicles, right? So that would be a tremendous environmental jumpstart if we could get those type of fuels. But we do think they're sort of out there time-wise. They're sort of near the end of the period we studied. Did we think they'd start to become possibly available, in the mid 30s? But again, I'm not an expert on that. And
Sure, sure.
our chapter sort of goes into sort of the pros and cons and feasibility issues of getting zero emission synthetic fuels.
Did the report have any specific recommendations on how the government can encourage consumer education on EVs or zero emission vehicles? Say, subsidizing consumers renting an EV for a period.
Yeah, we do have some on that. And again, drawing on some history lessons from other technologies that one of the key factors for people accepting a new technology, whether it's a different type of light bulb or a microwave oven or a different type of vehicle technology, is exposure to it, to not just sort of, hear, oh, this is electric, boy, that's different, it seems so foreign, but to actually, be in one and to drive one and to see how it performs. I was on driving in this morning, and the Tesla next to me just zoomed ahead of me, just from this red light, amazing acceleration that my gasoline powered vehicle wasn't able to match. And so I think as people get exposure to the benefits of these technologies, and again, we see that from the history of other technologies, that reluctance and psychological barriers are, brought down. And so ways to do that would be include things like pilot projects. Of course, just as the technology starts to spread, you start to have friends or neighbors or relatives who are going to buy one of these vehicles, and then you hear about it firsthand. Those type of firsthand reports from people you trust and know are extremely valuable in helping to build people's perception of a new type of technology. So, part of it will occur naturally if we can, stimulate enough people to buy these, and that will not only affect those people, but the people that are near them and know them will hear about these vehicles, see them, ride in them, and hopefully then be incentivized to buy them themselves. But there may need to be even more powerful direct programs as well. I mean, possibly even things like, public service announcements about, the importance of these new types of vehicles and how wonderful they are, how beneficial they are. Normally we rely on industry to promote its own products, but here there's a large social benefit in shifting to these type of vehicles. And if there are strong enough consumer reluctance or resistance or delay in adopting them, it may be worth a societal perspective to have more government playing a role as well as, other stakeholders in promoting these vehicles.
Michael or Bill, do you have anything to add on that particular question?
I'll just offer that I think that for a long time the industry, if you look historically, there's been a challenge maybe in terms of technology, how fast you bring technology on. Now, the biggest challenge seems to be shifting away from the technology itself, although there's still challenges with costs that I think Gary has mentioned. And it's more of a how do you bring consumers on board to these technologies, and with the auto industry starting to expand into new market segments, pickup trucks and more SUVs, things like that, I think that'll encourage more customers to come into the market. So I think that's a positive development, and I'm really quite excited to see how these vehicles meet the utility expectations of customers for those segments too.
And I would just say, first of all, thanks, Gary, for your presentation today. That was great, and for your committee and all the work. And I would not be truthful to say that I have read a 500-page report in 1 week, but we have started to look at it and really, really appreciate it, including, and I had not gotten as far as this part. I know it's one of the later chapters on consumer education. So we will definitely, I'm sure, not just EPA, but EPA and DOT and DOE and others, we will take a look at, what are the recommendations for what is the role of government? What can we do to help? Because I think that sort of like this ecosystem of, the auto companies themselves and the dealerships, and what can we do at the state and local and federal government level to help educate people about, why these products, as you said, not for the role of government to promote individual products, but talk about and figure out ways that we can help promote sort of like the technology or the need for low carbon. I think there is a lot of things that folks can do there, government as well as private industry, folks like in the utility sector and others on charging. So we'll take a look at those because I think it will take more than, certainly the one thing we know for this kind of transition is it's more than just writing down a standard. A lot more will need to be done. Thanks.
Gary, one of the questions from the audience was, how technology neutral do you think the government really is? They say the problem is GHG, not ICE. How do you feel about that?
Well, I mean, I think, there's enough promise and energy and investment going into these different technologies that we don't want to suppress any one of them.
Mm-hmm.
They all show a tremendous amount of promise. I mean, we considered whether it would make sense from an efficiency just to pick a technology and go with it, so you don't have to invest in different infrastructures and some of the duplications and inefficiencies that are associated with that. But what we found was that the commitment and the incentives and the investments and the potential of these different technologies are all very promising. And so I think from government perspective, they're going to see that as well, that they don't want to put their thumb on the scale if there are these different promising technologies, and that technology neutrality with the idea of a particular outcome that we want to achieve, however you get there is fine, because and as long as we can measure these, apples to apples. And so another key thing will be, the whole life cycle of the emissions from each of these technologies will be different. And to be able to measure that and compare that in some way and give appropriate credit based on that. But, I think we all became on the committee very convinced that that's the strategy to go, because there is so much promise in these various different technologies.
Yeah, and building on what Gary's saying, I think it's not just the promise of different technologies, it's the fit of different technologies with different consumers and different applications. For example, large heavy duty pickup trucks may be better suited towards a net zero carbon fuel than, electrification. And I'm just throwing out some examples here, but, different customers have different expectations of what their vehicles should be able to do, and different fuels and technologies will probably play into those spaces in different ways.
One of the issues that someone else brought up was if you're doing a transition away from gasoline, a lot of the roads that are funded are funded through road taxes. And a lot of that is gathered from fuel taxes at the pump and at the state level as well. And did you guys look at what are some of the issues related to if you actually move away from gasoline, how do you collect those road taxes?
Not in much detail. I think we do mention that, maybe we have to go to, through a miles traveled tax or some other mechanism other than paying at the pump, maybe through insurance or some other mechanism. But yeah, that is an issue for sure. Already we're seeing it, right? Apparently the revenues from the road tax is going down as people are already starting to drive more efficient vehicles like hybrids and things like that. We're already starting to see an effect of that. And it's not fair that, only some segment of the road users pay the highway fee. It should be across the entire fleet, spread fairly. So I think we will have to move to a different type of system from the pay at the pump tax to pay for roads. Exactly what that is, we didn't go into in any depth other than to note it as a problem.
Now, you looked at a lot of issues related to the interactions between NHTSA and EPA. Did you see, when you look at the way the Europeans deal with these issues, it's really just focused on emissions. It's really not focused on fuel economy. Did your folks talk to you about the reasoning behind, and I think Bill can answer this probably later on in his presentation, but the people that you were talking to mention the disconnect between the way other countries are measuring and dealing with these issues and the way that we deal with them?
Yeah, so I mean, we did get some suggestions that, the CAFE program should go to be a emissions program. But, essentially EPA is already doing that. And we do think there is a unique role for the CAFE program in addition to the EPA emissions program, where, things like, maybe energy security is not a huge issue right now as we become self-sufficient, but it could be again in the future. Energy conservation, just as a general approach, is an important part of the whole situation, and that's what the CAFE programs focus on. Safety issues of the trade-offs and the size of vehicle, that's again an issue that NHTSA deals with. And so we do think there are sort of some unique elements of each program that are synergistic when they work together, and that we shouldn't merge them into be completely just one program, at least at this time, that the two programs should both continue. And, we do think it's been great how they've been able to work fairly well together.
Michael, the manufacturers, how do they feel about this?
Yeah, it's just an interesting question, Bruce. I'll have to be careful what I say here, but we've always advocated for essentially one national program, either a coordination or a harmonization between what are effectively three different regulations in the United States, if you count state level regulation by California. And it has been a challenge that because of the differing statutory constraints that the two agencies, EPA and NHTSA, operate under, what's intended to be harmonization doesn't always end up in that way. For example, manufacturers, I don't think, have run into any compliance problems. They've run into compliance challenges, and have, had to work hard to stay in compliance with the EPA program. But even while they're complying with the EPA program, they're still paying hundreds of millions of dollars of fines into for violations of the CAFE program. So again, it kind of boils down to the statutory way the statutes handle these different programs and constrain different portions of the agency's abilities to create a regulation that's completely harmonized between the two. But I think that Gary brings up a good point, that there is a role for both agencies, and they both bring a unique perspective. And in the longer run, I don't know where that might go. I think there's still some roles to play, but I think that's something to be considered going into the future, is how do you continue moving forward with a three regulator system in the United States? And that's not to pick and choose which one or which ones should be involved, but there's certainly inefficiencies associated with it, in addition to some benefits associated with it.
Yeah, I think Michael makes a good point. I guess one of the things we saw is that there's a potential, as we go to a zero emission fleet, that at some point they're all going to converge on that basic reality. And at that point, the differences may be insignificant. And so there's a hope that just because where the technology is going, that within a decade or two, we would be at essentially a zero emission vehicle fleets, and those are going to be, the CAFE program, the California program, the EPA program will all converge on that.
It does bring up some interesting questions in the transition time,
Yes.
right? They,
Yeah.
you know, how do you deal with a program that in the NHTSA perspective, you know, can't consider electrification, at least currently,
Right.
when it's setting regulations, yet those vehicles are going to have a huge impact on the compliance levels. And, you know, what does that do for the ICE type level of regulation?
Yeah, I mean, if that problem is not fixed, I mean, we think the CAFE program will erode into insignificance because EPA is not so restricted. And so EPA, we think, should go ahead and go where the technology is available. And that would leave the CAFE program behind. If the CAFE program cannot consider alternative fuel vehicle or zero vehicle emissions in setting their standards, they'll just become, you know, relatively insignificant and fade into oblivion. So, you know, that's why we think it's really important to correct that artifact of, you know, 20, 30 years ago that was put in the statute at a time when alternate fuel vehicles were not seen as a major part of the fleets. Now that they are going to become that doesn't make sense to have that in the statute any further.
Now, Gary, the close to the last question for you. In your analyses, in your research, did you weight the potential technologies, regulations, and support for the manufacturers and suppliers, meaning in the results, are certain technologies, regulations, or incentives considered more effective than others?
Just, you know, the fact that, you know, we think technology neutrality is critical, that, you know, we were really struck by the different approaches different manufacturers are planning, that they are determined and dedicated to developing those technologies towards a zero emission future, and that should be encouraged and allowed. And so, you know, to allow, you know, as long as we set the long-term performance goal and maybe the stepping stones to get there, you know, that the important thing is to allow engineers to basically engineer a way to get there, you know, and allow them to try different methods. And if some sort of fail in the marketplace and aren't as successful, then they will, you know, go away, and the winners will succeed. And so, you know, but maybe as Michael was saying, different users may want different types of systems. You know, if you're driving a larger vehicle for long distances, maybe you would rather have a fuel cell hydrogen vehicle than a battery electric. Whereas if you're, you know, more of a consumer use and driving to work and back every day, you might want the battery. So, you know, to allow consumers to choose and allow manufacturers to choose. And we think as long as the government, you know, sets a goal, that should be able to work itself out.
Very good. Thank you very much, Gary.
Thank you.
We'll bring in our next speaker, Congresswoman Debbie Dingell. Thank you very much for joining us, Congresswoman Dingell.
You are welcome.
She represents the Michigan 12th District of the U.S. House U.S. House of Representatives. She is a member of the House Committee on Energy and Commerce, where she is focused on forging bipartisan solutions that support Michigan's families and economy, including improving long-term care and ushering in the future of the American auto industry. Before being elected to Congress, Debbie worked in the auto industry for more than 3 decades, where she was president of General Motors Foundation and a senior executive responsible for public affairs. Again, thank you for joining us, Debbie. I appreciate your taking the time. I know you have a 10:30 hard stop here, so I'll let you go and take it away.
Thank you, Bruce, and thanks everyone for having me here today. And I sure look forward to the day that we're not all in boxes and we're back in the same room. The work that you're all doing is so important to Michigan and to our country. From in-depth research to advocacy to continued thought leadership, thank you for all the work that you do to advance the auto industry. As you know, I'm a Michigan girl, and Michigan's the global center of the auto industry, and my intent is to keep it that way. As someone who has worked in the industry her entire career, I tell everybody in Washington I'm a car girl. I'm proud of it. I can tell you that there's never been a more exciting time in this industry. We're watching the auto industry transform itself into the mobility industry right in front of our eyes. The change is happening faster than many people expected. This technology is developing fast, and we have to ensure that the United States remains on the forefront of innovation and technology. This is especially timely as Congress begins our work on the infrastructure package. That's why we are already working closely with the Energy and Commerce Committee and the leaders in the auto industry to manufacture the vehicles of the future right here at home in Michigan and the United States, invest in necessary charging infrastructure, and establish the federal framework for autonomous vehicles. It's clear that it's time for the United States and US companies to take the lead, but it's not going to happen if we don't act now. That's my message to all of my leadership. Joe Biden on down. Our federal policies need to keep pace with innovation to allow it to thrive. We also recognize the need to act fast to electrify the transportation sector and to strengthen our domestic manufacturing and jobs, building the vehicles of the future here in America. And we're at a critical point in incentivizing our EV production and charging infrastructure. The federal EV tax credit has proven to be incredibly beneficial. And we also need to establish greater incentives for manufacturers to build and retool factories to build the vehicles of the future. That's why I introduced my USA Electrify Forward Act to craft a suite of policies together to grow US electric vehicle manufacturing jobs, production, and deployment, and encourage the investment and expansion in the necessary EV charging infrastructure. I tell people three things. A lot of people, everybody's talking about EVs. We need to build them. We want to build them here. We want to create American jobs, and we want the consumers to buy them. That requires three things. One, people need the three buckets I talk about. One, they need to be able to afford them. That's where tax credits matter right now, how companies, how much they price them at, et cetera. Two, people have to have confidence in electric vehicles. So the second bucket is the battery. And we've got to develop batteries that are going to have range so people trust them to have range. And we got to build those batteries here. Here is a reality. The internal combustion engine has more jobs than an EV does. But we got to build the batteries here in America. And we've got to do that. And I'm working very hard on that. That's why I've got some policy I'll talk about in a minute on that. And the third is we have to have confidence that they can charge, that if they're out in the road, they're going to have a charging station. We're going to have to put charging stations at homes. And all three of those are going to be absolutely critical if the electric vehicles are going to be successful in this country. That's why I'm working with my colleague, Representative Brownlee from California, to introduce the ATVM Futures Act to modernize and expand the Advanced Technology Vehicle Manufacturing Loan Program at DOE, which is used to build and retool auto factories in the United States that are making advanced vehicles. And we're also working to have DOE invest in R&D that will help build out that battery. These are really important programs. But with this movement, with these programs that we need, comes immense challenges and opportunities. Autonomous vehicles, and I've talked to my chair, Frank Pallone, Jan Schakowsky. We are working to try to move that legislation in committee, potentially, don't hold me to anything, in the next few weeks. We got it through the House unanimously, the Congress before last. Last Congress, we never touched it. The United States isn't going to stay at the forefront if we don't do that. If we do it, we've got the opportunity to reduce 38,000 fatalities we have on our roads each year, and to provide new mobility services to senior citizens and people with disabilities. AVs have the possibility of potentially reducing emissions and improving congestion on our roads as well. But we've got to get the policies right. And that's why we're working so hard on autonomous vehicle legislation. That's where bipartisan lawmaking comes into play. We need support from all sides, both sides of the aisle, from our auto leaders and our stakeholders. Many of you are in this room today to make this change happen smoothly. Yet the time for swift is now. And I'm hopeful that we can find common ground. It's time now that we need to work together to build a better future, creating new jobs and making our roads safer. Designing and building the next evolution of vehicles is an opportunity to ensure we remain at the center of the global automotive industry. This is about keeping our communities in the United States at the forefront of innovation and technology, including advancing autonomous vehicles, EVs and infrastructure, and the future of mobility. On all of these fronts, I'm optimistic we can make significant and meaningful strides this Congress by moving this legislation forward. And one of the other things I'm hopeful of, I've been spending a lot of time with all the stakeholders. Last year, I was spending time with the environmentalists, the unions, the companies, trying to find common ground on fuel efficiency standards, where we're going to go on EVs. Right now, I will be very honest. The environmentalists want to set a standard for 100% ZEV mandate by 2035. The unions are really worried that, and I'm going to tell you, I hear it when I'm home each weekend. Union workers are coming up to me and saying, I'm afraid you're going to cost me my job. I spent 2 years in between everybody, and it wasn't a pleasant 2 years as I told the Green New Deal people, labor's got to be at the table. Well, I've got them together. A couple of weeks ago, I had the heads of all the environmental groups, LCV, EDF, NRDC, all the letters, Sierra Club, Union of Concerned Scientists, CAP, and the UAW in the same room, listening, not talking past each other, listening to each other. And it was a really good conversation. We've got a work group. Autos got to be at the table. Suppliers have to be at the table. We've got to find a way we're bringing everybody at the table and finding that common ground. And that's what I'm committed to. It's hard work. We got to be intentional about it. We can't just spout words past each other. We all have the same goal. We want to keep strong manufacturing in this country. We want to protect and create good paying jobs. We want to see our economy strong. We want our customers to be happy. And we want to protect our environment and protect it for future generations. There's a lot of work, and we need to be very intentional about it. And that's what I'm trying to do right now. So with that, I'm looking forward to your questions. And we all got to all work together to attack this very aggressively. Thanks, Bruce.
Thank you very much, Debbie. We got a few questions from our audience. I guess one is kind of a I don't know, pessimistic story question. Is the administration jumping the gun by incentivizing vehicles that do not meet all the benchmarks set by internal combustion engines?
I'm not even sure what that means. I mean, we've already had tax credits for electric vehicles.
Mhm.
The cap on a couple of the companies, Tesla and GM have reached their cap. There's a lot of discussions on that. Quite frankly, Debbie Stabenoff's been, I say to everybody, I take the tax credits and leave that to Debbie Stabenow and Dan Kildee, and I'm doing I'm sitting down at the table and having these other discussions on really tough subjects. But all the companies are saying they want to move to the electric vehicles.
Mhm.
It is where we're going to go in the future. So, you're not going to be successful if you don't sell the vehicles. So what will make the consumer buy the vehicle? And those are all the pieces of the discussion right now, as I laid out in those 3 buckets. That's my definition of what the 3 buckets are.
Sure. Can you talk a little bit about the new AV legislation that you're working on?
Well, I mean, it's not so new. We've actually been working on it for, as I say, I was very proud of the fact that even Justin Amash voted for it 3 years ago when it was in the 115th Congress. Unfortunately, we could not get leadership to move it in the last Congress. We need to establish a framework by which people can build and operate these autonomous vehicles. There have been a lot of tough issues. We've reached agreement on some. Some are still being discussed, but I am hopeful that in the next few, and it's been suggested to me that I not get into the detail, that I not negotiate at these kinds of events, but stay at the table.
Sure.
But you all know what some of the issues are. I mean, anybody, it's preemption, it's some of the legal issues, but we're working it and we've made progress. And I continue to be optimistic. We have to, because if we don't get this done, other countries are leading. China's out there. I am not going to secede jobs from the United States of America to China anymore. India's out there. We have lots of other countries that are going to be at the forefront. We can't cede that leadership. We need to keep it right here, which means we got to roll up our sleeves, which I've done, and get at the table and figure it out. And that's what we're doing.
What do you see as some of the challenges that when you are working with the labor groups and the environmentalists in those meetings? What are some of the major challenges you're working through?
Well, look, I'm very intentional. I've suddenly found myself using that word intentional because, I mean, I did not sign on it. It's documented fact. I had a lot of protesters, many of the places I was in the last Congress, because I didn't sign on to the Green New Deal because labor wasn't at the table and labor had concerns. I went to the environmentalist community 2 years ago and said, okay, we have to have labor at the table. And labor's worried about labor, by the way, it cares about the future of the environment as much as anybody else. They're worried about their kids. They want to protect our environment. They want us all to live in a safe place. But they also want us to have policies that are going to protect their jobs and keep jobs in the United States of America and create new ones. So, and that we have lost a lot of jobs. I don't think I'm going to go off track a little here, understand what's happened to the supply chain in this country until COVID. And suddenly when COVID appeared and we didn't have PPE equipment in this country, 90% of generic drugs are being made in other countries and imported here. We realized the national security issues, the healthcare issues that have arisen from being so dependent on supply chains in other countries. Well, now in the auto industry, look at what's happening with chips. Today you read there's a rubber shortage. We've become so dependent on other countries. They're shipping jobs overseas where they pay much less, don't have benefits, and don't have the environmental standards, quality standards that we have in this country. We got to figure out how we bring those supply chains back. We have to figure out how we pay a decent wage, we have safe working conditions, we meet environmental standards, and we compete in a global marketplace. Those are tough discussions, and clean up the environment at the same time. Those environmental standards were a big discussion when we were having, I called it NAFTA 2.0 discussions. So those are the kinds of discussions. But there isn't war at the table. Environmentalists are saying, we're going to have a calamity if we keep going where we are. And they've got studies that are very methodical about why they picked this year. And UAW's got very methodical studies showing what's happening in the workplace. And you try to find that common ground. That's why we have a work group.
Very good, thank you. And when you were talking about this labor story also applies, and as you were mentioning, to NAFTA 2.0 and the new USMCA. When you're talking about trying to keep jobs in the U.S. within the context, how do you do that within the context of the USMCA? You've worked in the auto industry, so you know that the manufacturers they're one of the reasons that they went global was that they were trying to maximize profit. How do you see us managing those kinds of issues where where you have the profitability of the manufacturers that are, trying to make their best profit, and at the same time, trying to keep things local?
Well, I think it's one of our huge challenges, but we also have to, I think we need to, as a country, be, we're importing steel that's, I quite frankly would call substandard. And we've seen it used in some bridges that have collapsed or other kinds of issues like that. These are very intentional discussions that we have to have. And it's very hard to be broad because you almost have to go after each product one by one or which company. But at some point, you have to, you want corporations to be profitable. I'm not, but how profitable do they have to be? I think that we need to pay wage employees a decent wage, and that they're entitled to benefits, and that they need to work in safe a safe environment, that there should be OSHA standards. Many workers in other countries aren't working under those kinds of circumstances. I mean, when you look at what workers were being paid, they're working in the exact same plant in Mexico and were being paid $3 or $4 an hour and didn't have any benefits. I don't think that's right. And I think we've got to start to fight for workers in other countries too.
Did you see the new USMCA helping in any way in terms of helping labor within those other countries, forcing labor in those other countries?
Well, it is trying to. And Mexico, as you know, is very anti-labor. There have already been a number of incidences where people have been arrested and they have been resisting, and we have to make sure that USTR is enforcing parts of the, I always want to call it YMCA, but the UMCA, and people don't know what it is, which is why I still always call it NAFTA 2.0, because the union workers know what NAFTA 1.0 did to them, and they know what NAFTA 2.0 is. And I'm in conversations regularly with Canada, which does not have nearly the issues that Mexico does. Mm-hmm. But I'm meeting with State Department today, as a matter of fact, on some of the Canadian issues. But these issues matter.
One of the questions from our audience was, in terms of regarding the semiconductor shortage, should a portion of the proposed $50 billion funding be set aside for the auto industry?
I am, again, sometimes you don't negotiate in public, but there are discussions going on. You saw that there was the meeting at the White House yesterday. It is a real problem. I think we need to, anybody here that's got ideas for me, I've been talking to everybody about public policy ideas that would bring that chip production back to this country so that we aren't dependent upon foreign countries and we're not interrupting our production. And I think we have to find, if we want to rebuild our economy and keep it strong, we got to keep these plants producing. We got to keep our workers working. We got to keep them safe too in these days of COVID. And we have legislation in to address this issue as well. So yeah, we got to do some things to address this very real problem.
Debbie, I think that's all the questions we have for you today. We'll let you off.
It was wonderful being part of you. I wish I could be there. I've got a hearing at Energy and Commerce, but I'm going to keep working these issues, and anybody with any ideas, contact me anytime.
Thank you very much.
Thank you.
Take care.
You too.
Okay. Our next speaker, Peter Fagee, received his PhD in physical electrochemistry from Case Western University and has had full careers in academia, in the private sector, and now in the U.S. federal government. He has created and managed research and advanced technology programs across several fields, including battery materials and manufacturing processes. Within the Department of Energy, he manages a large portfolio of R&D projects in the Office of Energy Efficiency and Renewable Energy directed at realizing the promise of next generation lithium batteries and advanced processing and processing science and engineering. Welcome, Peter.
Good morning. Thank you. I'd like to first let me introduce myself. My name is Peter Fagey. I work at the Department of Energy. I've been there since 2010, but before that, I'd spent about 10 years in Detroit. I lived in Detroit working with a company called Energy Conversion Devices, a very idiosyncratic, well-known company in the Detroit area that was up north of the city, working in their fuel cell joint venture with Chevron Texaco. I spent a couple of years there, and then for the remaining years I was in Detroit before I came to Washington. I was a consultant in the space of things like fuel cells and electrochromic devices and batteries. Since 2010, I've been working at the Department of Energy in the Office of Energy Efficiency and Renewable Energy in the Vehicle Technologies Office as a subject matter expert in batteries, battery materials, manufacturing of battery materials, testing of batteries. I work on a team where there's about 8 of us who work on managing a large portfolio of projects where not a particularly visible group, but to the stakeholders in the community, and that means the car companies, the national labs, university researchers, startup companies. Our programs are very well known. What I'd like to do today is talk a little bit about the context of applied battery research in, considering the perspective of this conference, but also trying to give you a flavor of what we're doing. It's very complicated, I guess is the best way to call it. How things evolved in terms of research, where you're supporting more fundamental research at the universities, but you're also working directly with companies like GM and Ford in testing battery packs, and the ways these things are done, the types of activities, the intellectual property issues, there's international issues, and then there's the really interesting stuff to people like me, the scientific part of it. Let me get my presentation up. It's the beginning of it. Okay, that would be, where is that screen? Are there more screens here? I apologize.
Down at the bottom, you have to share your screen. There you go.
Yeah, I think that's it. Let me.
Yep.
Okay, can everyone see the full screen?
You're fine.
Okay, great. Let me get started. So, I guess I've gone through this title slide, so let me just jump right into the structure. And I think it's important to understand the structure of how things are getting done with respect to the taxpayers' investment in advanced battery research in the United States. First, a little philosophical sidestep, and that is to mention, why should the government be involved? And the government necessarily, and I believe this strongly, and willing to talk to anybody about it, the government absolutely has to be involved when the risk-reward ratio is such that the risk is absolutely massive, but the reward's even bigger, and there's a necessary long time frame involved. The only investment partner, if you like, who can handle the time frame for some things, especially things like battery research, is the government. So the government really plays an absolutely crucial role. The idea that electric vehicles would be where they are in the world right now without the investment of the taxpayers of America in the Department of Energy is absolutely ludicrous. In fact, you can ask any battery expert in any country in the world, and they will tell you that without the investments into the agency, the organization where I work over the last 15 years, we wouldn't be where we are in the world. So what does that structure kind of look like? The first thing is that battery research at the Department of Energy doesn't only take place where I work. That's the Vehicle Technologies Office. That's the puzzle piece in the top center. When I first put this slide together, the sort of trapezoid pieces at the end, the geothermal office, the loan program office, the Office of Technology Transition, they hadn't been included, but now we're including them because they play an exceptionally strong role because of the development of this supply chain, because of the President's executive order from February, which I'll talk about in a minute. As Congressman Dingell mentioned, the AVTM program in the Loan Programs Office is essential to getting the pre-commercial into commercial. So those things that are invented here that are really going to make a difference, that are going to be in cars in less than 5 years, that will create U.S. jobs, that will solidify IP here. The last step of that is not something that can be done by a research agency or by researchers. It's a commercialization, and it requires capital and planning. And the loan program has about $17 billion available to lend into companies that advance this mission. And as Congressman Dingell mentioned, that's evolving as to whom they can lend it to and what that program looks like. And I fully expect that will be able to move down the supply chain to get into things like materials producers, recycling companies, and even into extraction. The geothermal office is involved because we have an enormous lithium resource here in the United States. The giant aquifer under much of Arkansas and all the way up into Canada has got a significant amount of lithium brine. Right now, the majority of lithium that's used in the world is extracted from dry desert beds high up in the South America, in Chile, Argentina. And the reason it comes from there is it's really easy to pick up. But of course, you have to clean it up and you have to move it. And for example, water is a huge problem for them in their extraction process. In North America, we have brines, and we also, the Canadians have deposits of ore. The Australians have a lot of ore, but it's harder to get the lithium and other metals that are needed for batteries out of ore. So that's the nature of these various agencies. Basic Energy Science funds a lot of research into electrochemical energy storage at universities. The Office of Electricity has recently got involved, and I'll mention the Energy Storage Grand Challenge in a minute. They're focused on stationary and grid storage, which will play an enormous role in our future society. You know, all smart devices, the ability to use electricity a lot when it's cheap and store it when it's not is going to be a big part of our society as we move forward. ARPA-E is a transformational agency. It sidesteps the usual organizations within the Department of Energy. It has its own unique structure. It puts together FOA's funding opportunity announcements that are quite unique to various necessary areas that really try to leverage exciting frontier research that may be coming out of a university or a national lab or a startup that may nucleate, maybe across several different companies or universities, and then put it into a package where they can apply for funding to try to take it to the pre-commercialization stage. Recently, the Advanced Manufacturing Office is beginning to play an important and increasingly important role in the fact that we're going to have to make a lot of batteries because eventually all cars will run on batteries. Maybe not on batteries, but some sort of electrochemical energy storage system. Eventually, there will be a need for a large manufacturing infrastructure in the United States. And there are R&D aspects of that early in the development. How do we make these things? How can we make new technologies, bring them into the marketplace that allow us to make batteries, to make materials for batteries in a way that is cheaper, safer, more cost-effective, more environmentally benign, more secure in the sense of critical materials and national security. All of that's true about battery materials research as well. But the interesting thing about manufacturing research is that if we invent systems in the United States that are completely different than existing systems, that hit all the buttons and are able to do things in a way that's far more attractive, then we level the playing field. All of the plants built in China have to be rebuilt. Everybody will try to adopt the new technology, but we started the new technology. So I think processing science and engineering support is vitally important to that. If we want to level the playing field with the existing dominant manufacturing that exists in China, what we have to do is make batteries in a different way, make it better to make batteries in a way they're not being made now. So I mentioned a couple of things. Let me talk a little bit about two programs that reflect some of the strategic thinking at the Department of Energy. In the last administration, two different major programs were set up. First, the Energy Storage Grand Challenge, which stems from a lot of congressional push to do something about next generation energy storage technologies as needed in the stationary and grid storage arenas. That's evolved into a major program across the national lab complex to develop programs, to look at what's available. There's a number of different task forces involved in looking at different aspects of it. It's not only battery energy storage, it also involves thermal energy storage and chemical energy storage, and hydrogen and fuel cells, among other things. Biofuels is involved. That I expect will grow increasingly more important as the administration rolls out its decarbonization strategy. That isn't involved directly with automotive batteries, but the battery of choice for automotives is, at the right time is lithium-ion batteries. They will also play a role in stationary storage. We've all heard of Tesla's Powerwall and a number of different stationary systems that have been built. These are essentially car batteries repackaged into stationary systems. So there is some overlap in the manufacturing space, in the utilization space. There's also some discussion of something called second use. If anybody's interested in that, we don't have time to go into that right now, but that's of interest to the Department of Energy. We're looking at various ways people might do that. The other strategy that's been realized very recently, the last 6 months, is a federal consortium for advanced batteries, FCAB. That's a within the government consortium that involves the Department of Energy, Department of Commerce, Department of Defense, and the Department of State, as well as other actors within the federal government that have a stake in lithium-ion batteries, that are using them now, that need them made, that have issues with things like intellectual property. How are things being done? How do we test them? How do we buy them? And that is an evolving process with several task forces that are working together to establish things like testing protocols, science and technology, risk matrices, among other things. And I think you'll hear more and more and more about that as time goes on. I should mention that the strategy is evolving, and with the new administration on February 24th, President Biden and put out this executive order on America's supply chain. That's causing a lot of work for us, and that's good work. It's something we're very happy to do in the Department of Energy. Basically, we got to position U.S. domestic battery supply chain to grow and to flourish in the United States of America. And that means the 5 bullet points at the bottom. We need access to raw materials. We really need to support domestic battery material discovery, development, and processing. We've got to get to manufacturing at scale within the U.S. And we really want to look at this, at promoting end of life and recycling. Battery materials are expensive, they're heavy, batteries do die. One of the best examples of recycling in human society is lead in car batteries. We need to take that to a whole new level with lithium-ion batteries in automobiles. That's a very important aspect of our work. This executive order is, the first response to that is an outreach to corporations, entities that wish to respond and tell us what they're interested in, how they view this. That's being assembled right now, and I expect that there'll be more public-facing information from that shortly, let's say in the next 6 months. Okay, so let's get into some of the things I know far better than all of that, and that's the science and engineering. So I work for an applied agency. That means that we set quantitative targets that we feel that the technology development community, the research community, the startups, the OEMs should be able to get to. And we do that based on a lot of measurements that are done. I'll mention that later on in the talk. We're the agency in the United States that if you make a new battery, we'll test it for nothing for you. Anyone who calls me, I will make arrangements. I'll get them to the right person. But if there is a device that stores energy that could be used in an automobile, we'll consider testing it. And from that testing, we go all the way up to things like what Tesla puts in its cars. These systems are measured as modules, so that's an agglomeration, if you like, of numerous batteries in various configurations that are put together as the power and energy source for an automobile. These are tested at national labs, and things are measured that are associated with them. And one of the critical things is how much does it cost per kilowatt hour? Per kilowatt hour is the equivalent of, one could think of it as gasoline, but it's not just gasoline, it's gasoline and the engine. So it's the energy that is available in the car. And we set goals. When I joined DOE, the established numbers, so from all the measurements that have been done at the national labs, a compendium of work that's been going on for a number of years, those numbers are then massaged through techno-economic analysis to say, well, what if you made 100,000 of these things right now, assuming you could make them at reasonable cost, et cetera, et cetera? What would dollars per kilowatt hour be? So in 2010, it was almost $500 per kilowatt hour. In the last 10 years, the DOE, last 15 years or so, the DOE's been publishing that number. It's gone down by 80%. It is 1/5 of what it was 12 years ago. And to give you a point in space, a few years ago, $125 a kilowatt hour was price parity to an internal combustion engine. That number's dropped a little bit. Tesla will give you, and GM will give you numbers like they can do 80. I fully expect we'll be doing 80 soon. What does that mean for all this? Well, if they're as safe as internal combustion engines, if they're mass producible, if we can get below, let's pick an arbitrary number, 80, that doesn't mean electric vehicles will eventually be used. That's a tipping point. That means they will be used more and more and more. The exponential slow growth of the use of electric vehicles will be replaced with an exponentially rapid growth, with the caveat that a car in the United States right now has about a 15-year half-life. So that means that 15 years ago, all the cars that were made, about half of them are still being driven. That's a really large lump of a large commodity used by society to get through, if you like, before you'll see penetration. So we live in really interesting times in terms of the development of electric vehicles. So what are the major challenges to getting that out there? Well, we got to reduce battery costs, initial costs, and life cycle costs. So how long can the battery be used in the car? And basically, how much material do we need to put in the battery How big does it have to be in the sense of the materials that store the energy? The less we can put in, the cheaper it will be. And the next thing we want to do is eliminate dependence on critical materials. And that's directly right now, and primarily cobalt, because cobalt has a very, a very bad trail to utilization, in that it's predominantly, well, exclusively mined in the Republic of Congo. It has a lot of issues associated with child labor. It's no hyperbole to call it blood cobalt, like blood diamonds. And in fact, we got to get rid of it just for ethical reasons. But then layer on top of that the cost of it will skyrocket as use goes up. It just becomes impossible to build batteries with cobalt in the near future. And right now, all of our cell phones are built with cobalt as one of the main constituents in the cathode, or as the only transition metal in the cathode. And that's because it makes such a very good battery. Well, that dependence needs to be gone. We got to get cobalt out of batteries. And I can say that I think the research that's done around the world, and especially here in the United States, and the adoption of the car companies of battery technologies that have very little cobalt, I think that's going to be quite successful. And then the last challenge is that we're used to refilling our automobiles at a gas station in minute, 2 minutes. That's not possible when you're not moving. You're moving chemical energy, but not as a mass on whole. You're not moving a liter of gasoline in a couple of in 10 and 15 seconds, but you're actually moving the energy through a system storing it in one kind of material, and that takes longer. But there's no doubt about that. It's hard on the battery if you try to charge it fast. There's safety issues. So what we've got a significant program on is how to develop safe batteries that charge in less than 15 minutes. And one of the interesting issues with that is that you can do things from a research sense to really increase the speed. You can make materials that charge extraordinarily fast, but in only small amounts of energy. Well, what do you want? And what happens right now, the utilization of cars will be different in the future. We talk to our cars. We have TV sets in our cars. This isn't what it was like 20 years ago. We use our cars very differently. We have gig economy aspects to transportation that didn't exist. So how will cars be used in the future? Do we really need to have fast charging, or is the main use going to be people parking it in their garage overnight when it could be charged without any real damage to the battery? So as we develop safe batteries that charge in less than 15 minutes, the utilization curve is unknown because all of this is being developed. It's really an extraordinary confluence of technologies being developed from the laboratory, from the idea stage forward, and hungry multinational corporations wanting to scale that right away. It's a really exciting place to work right now. I have to say that. So this is a very busy slide, but let me try to get through some of the things. We can't talk about everything. If you have questions about any of what I've said, you can reach out to me. You can reach out to other people in our office. But this is sort of a map of what goes into the supply chain for lithium-ion batteries. And predominantly, that's all I'm going to speak about, because that's all that's really important in the next 5 years for the automotive market. Despite what you'll hear about solid-state batteries and magnesium and other forms of electrochemical energy storage, they're just not going to be ready for prime time in any reasonable amount of time to get to the sorts of performance standards that exist right now for lithium-ion batteries. Lithium-ion batteries exist right now that can give everything that's needed in a car, with the exception of cost and perhaps range. The safety paradigm is different. One could argue that gasoline's more unsafe than lithium-ion battery, but a lithium-ion battery also goes into something called thermal runaway, which can be extraordinarily dangerous in that it doesn't need oxygen around, doesn't need air around to start a fire. It actually makes its own oxygen under abuse conditions. So the buckets there: raw materials production, materials R&D and processing, cell R&D and manufacturing, end-of-life recycling. This is a view on the research, development, and innovation needs. And across the top, we tried to capture with sort of cartoons or icons what some of the major things that needed to be considered. So in raw materials right now, the important raw materials are lithium, cobalt, nickel, and graphite. Cobalt and nickel go into one side of the battery, and graphite goes into the other side. There are lots of other things in there. There's manganese in there, there's aluminum, there's copper, but that's not as critical as those things. We move down the raw materials column. The cartoon that says CMI is the Critical Materials Institute, which is a multi-organization funding agency and information gathering entity within the Department of Energy. That's dealing with incorporating all the critical material aspects of batteries into their larger portfolio of critical materials that exist for supercomputers, for motors, etc. And certainly cobalt is a very, it's got a really big red dot on it. Lithium too, to a certain extent also. And shortly I will predict that nickel will be, we'll actually have to get nickel out of batteries, but that's a discussion for another day. In materials R&D and processing, there's a lot of work going on because that's where the rubber meets the road, because you have to make these materials that work to store electrochemical energy. You have to turn them into devices that you can use to put electricity in and take electricity out. And that involves turning these powders into electrodes, which are sort of like thin layers of an agglomeration of material that sit on either side of a metallic conductor, separated by some inert material that has a liquid electrolyte in it. So you have to make electrodes. And electrode processing is a very almost artisan task. There's so many trade secrets associated with it. There's so many ways to do it wrong, and there's a few ways to do it right. And there's a great deal of research and development and scale up going on in that arena. And then we have vested programs in something called low and no cobalt, where we're trying to get rid of cobalt, and then we're trying to work on silicon anode materials, because silicon will bring a lot of energy, extra energy capacity, in the sense that it stores a lot more energy than graphite does on the anode. We have similar programs as we move along towards commercial manufacturing. We have programs in cell R&D, in manufacturing, and end-of-life recycling. I'd like to mention, because this is a Detroit audience, the U.S. State Advanced Battery Consortium, which is an entity jointly funded by the U.S. government and the big three that exists in the office here in Southfield. And funding from the United States government is ministered by USABC for pre-commercial projects. So to be able to build battery packs for cars with the newest technology, to help move forward this so-called chasm of death that exists with new technologies versus widespread adoption. The squares along the bottom are trying to convey that this is not just done by DTO, but that other agencies are involved. That Basic Energy Sciences, through its centers, does a lot of work on the new materials. Geothermal's involved in extraction. ARPA-E across the materials R&D and processing spectrum. And the Advanced Manufacturing Office is looking at all of these things with respect to how do we do things. I won't spend a lot of time on this, but just to show that in the last 5 years, through our agency, there's been, I believe it's a little over $50 million put on the street to do all the things that Congressman Dingell talked about and that I've mentioned here, to get that supply chain here, to get the intellectual property here, to train the scientists to work on these things. This is not a slide for this presentation, but I didn't make it for this presentation. It exists for other ones. And it's broken down into 3 colors because those are kind of loose buckets of work in terms of the battery chemistries where the money's been spent. The bottom one, lithium metal, is quite an exciting area. If we can get lithium metal anodes to work, that would really increase the energy density of automotive batteries, and it would be a paradigm shift in the cell technology. But it's a really hard reach. It's also absolutely necessary for electric aviation, which is something else we're we're working on with NASA. So what does this look like in a sort of big picture? What are we trying to do? So we're trying to drive these system costs down. And year over year, we've been doing that. And there's sort of three buckets of science work or materials work that exists. The interesting thing about the lithium-ion battery or the lithium-based battery that will be used in cars is it's not one chemistry right now. Well, yes, it is. It goes to one chemistry because of adoption, because all the manufacturers will move towards something. So the flavor du jour within next generation cars will be a very high nickel containing cathode material. That's sort of the bottom of the green bucket. Conventional lithium-ion technology was based on substantial amounts of cobalt in the cathode and a graphite anode. We're moving towards getting rid of that cobalt, but still include the graphite anode, which doesn't store as much energy as a silicon-based anode. Well, the blue box is what will be in our cars, I predict, in the next few years once we get silicon to work. And that will shift that, will jump shift the dollars per kilowatt hour down a big chunk simply because we'll more than double the energy density on the anode, which will allow for less use of the anode, to have thinner batteries, smaller batteries that will increase the amount of energy stored per weight unit, gravimetric energy density. And it will do another thing also. It will get rid of a lot of the problems that have to do with cold starts. The very interesting thing about lithium is that in the lithium-ion batteries, when we charge them now, lithium exists in the electrolyte as a cation, a positively charged species. And when we charge the battery, it goes into the anode and accepts an electron from the electric circuit and becomes something like metallic lithium. It's not really, it's not metallic lithium in the graphite battery. It's actually intercalated. That means it's stuck between the layers in the carbon, but it exists almost like it's a lithium metal. So it's got that negative electron associated with the lithium cation, and it's held there. And then when we discharge it, we get that energy back and run the car. What happens if we try to push it too hard? And that means we try to do things too fast. I mean, the analogy to human behaviors is a good one. We try to push it too fast, bad things happen. And one of the bad things that happens is that if the kinetics are sluggish, that's the terminology we use, and it can't go fast for some reason, like it's too cold, then the electron will find another way, another something to do, and it will make metallic lithium. So it will actually, instead of the lithium going into the graphite, you actually begin to form actually thin needles of lithium metal. And that's really bad because it's a metal, it will form, it gets sharp and spiky, it pushes its way through the battery and the battery shorts. So the chances of having a battery fire in February are much higher in Alaska than they are in Arizona, which seems counterintuitive, but that's the fact. We have to get away from that for safety reasons. With a silicon anode, that just won't happen. Okay, and at the bottom, that bottom fat arrow, there may be other technologies available for commercialization into cars, not before 2030. But who knows? Breakthroughs could happen, but I can't see it getting scaled to the level where it actually makes an indent. And there's a plethora of those that people talk about, solid-state batteries, changing from lithium to things like sodium, magnesium, or calcium. But my informed opinion is that through the length of this graph, we'll be working with lithium-ion or lithium metal-based batteries. Okay, another view of this. So this is, well, let's call this a U.S. view. This is a view that came out of a workshop that was held in October of 2019 in Ulm, Germany. It was a meeting of an AABA meeting, a long-held meeting among battery researchers, an international meeting. It's held all over the world, in which at this particular meeting, the organizers reached out to many countries to say, hey, what are you guys doing? What's going on in the world? Where's research? So I spoke at the meeting, represent the United States, and there were representatives from Germany, Japan, China, and the European Union who all spoke about programs that existed, what's going on, where do we want to go. And the results, the perspective of that was published in a what's called a journal article. That's the way that scientists talk to each other and send things back and forth. So this is in the Journal of Power Sources. It's a scientific journal, and it's a 4 or 5 page article talking about, okay, what are we doing? What's the perspective from various country views? And this cartoon is, I'll call it a Eurocentric model. We adopt some of the things associated with it, but the Europeans tend to be a lot more research pushing out, where I would say that our program is industry pulling up or society pulling up. I mean, we support a lot of research at the national labs and universities, but we're very cognizant that this is about electric vehicles. It's not about doing research on electrochemical energy storage. Okay, so what's all of that? Well, that's all the kinds of chemistry that may be involved that we may be able to work with as we move from where we are now to where the fleet could get very, very, very large. And we have programs in every one of those colors. There's work going on within the VTO battery portfolio in every single aspect there. Again, it's not a blind bet. We're not at the casino playing every color and number on the roulette table. These are calculated bets based on an informed stakeholder group telling us what we should be doing, us looking at what's going on in the world, where are there problems, where should we put resources, and this give and take, this dynamic feedback process evolves into funding opportunity announcements where we reach out to the research community and say, hey, we'd like to fund some people doing these things. All right, well, let me end with something I'm very proud at. I was at this meeting, and this meeting was held in Ulm in October of 2019. And in October is when the Nobel Prize in Chemistry is announced. And I happened to be at the meeting with one of the winners, Stan Whittingham, wonderful guy, he's a professor at Binghamton University in New York, was actually at the meeting. It was very exciting to see the students, a Nobel laureate. What's going on? This is just dull science. The cartoon or the picture on the right is from that meeting. I, without knowing about it, I had to give up and speak to the audience on behalf of the United States of America. I was representing the United States of America there. Across the board are some very prominent scientists working in the community, stands in the center, and it was a very, very exciting, very interesting meeting. On the left is a picture of one of our research consortia that, if you were paying attention, there was a BAT 500 sort of box cartoon in a previous slide. And that's a very interesting program where we're trying to get lithium metal to work essentially. And it's across many national labs, and there's university researchers. And a big chunk of it is carried out at UT Austin. And then this picture right here, that is Professor John Goodenough, who's at the University of Texas at Austin. And there's Stan Whittingham. And the center, 3 people work for the Department of Energy. I just wanted to show you that to give you a human aspect to the work we do. Let me end with that, and I'm open to take any kind of questions. Thank you.
Okay, thank you very much, Peter. Got a few questions for you. You crossed a lot of boundaries here, Peter, focusing on the different. When we look at we just did a study looking at battery suppliers in the U.S. And there are not very many U.S.-based large-scale suppliers. They tend to be Asian suppliers. What's holding back the U.S. companies? We did see a lot of R&D companies, a lot of companies doing small things, doing projects on a specific technology, but nothing at large scale. What do you see holding them back from becoming as competitive as the Asian suppliers?
Well, historically, I guess the best or the most common explanation for that is the nature of of how our capital system works, the capital that needs to go into a plant to build a battery is substantial. Battery plant, manufacturing plant is quite substantial. And unless there's a solid ROI, in other words, unless a lot of products going to go out the door the day the plant's built, the people with the money, including the companies, not just venture capitalists, don't have the appetite for that level of risk in the United States. In China, that risk is almost, somebody will argue, is completely assumed by the government. So those things got built. Here, that's not how we do things, so those weren't getting built. The demand is going to be there now. I think that everybody admits that, and so there's a kind of catch-up game going on. I think we'll see more and more of that. Certainly, we've seen announcements from lots of battery manufacturers about building plants here. LG is a major manufacturer of batteries in the world. We'll be building a plant here. Tesla's got its gigafactory. There's announcements about gigafactories that are under development in New York State. There are many others that are here. Most of them, I would venture to say, I don't know this for a fact, but this is probably true, are things that were started elsewhere that are going to be built here. And that's just out of the nature of how we build things in the United States. We're not going to change our system to try to copy someone else. We're going to have to build this within the framework of our socioeconomic system. And that's going to require a lot of involvement from the government and from private industry together, working towards that. And I think that Congressman Dingell made the same point. This is going to involve a lot of effort from the government to get people oriented towards that. But that's the reason why right now.
Did anyone else have any thing to add on that particular question? Peter, one of the other questions had to do with solid state batteries. When do we expect to see, will they reach mass market potential and in the US?
That's a somewhat controversial question to ask a battery expert like myself. We all have different opinions on it. The issue is that the actual materials that go into solid state batteries are rapidly being developed. We're seeing lots of interesting electrolytes. That's the thing that goes between the two electrodes that moves the lithium back and forth. They're getting better and better and better. What's not progressing at the same speed, and it's actually quite disconnected from the materials development, is the manufacturing. You know, we don't make any kind of complex ceramics on a large scale, and that's what this would be like. So while the semiconductor industry is going to teach us a lot about making solid-state batteries, and people are making solid-state batteries, very good solid-state batteries, the size of the solid-state battery needed for an automobile is just not feasible, and I don't see it feasible for decades. Having said that, there will be people who know more about batteries than I do who will argue that point and say, no, it's going to be 8 to 10 years. I don't believe that's true at all. I think it won't be 20 years before we'll see. If we ever see solid-state batteries in cars, we will see a lot of solid-state batteries in other things, in wearable devices, in the Internet of Things. All of this research in electrical energy storage means that the electricity becomes extraordinarily fungible in our society in the next decades. Everything will have its own power source. The idea that you have to charge your phone will be silly to our great-grandchildren. Why charge it? You just get a new one after a year when the battery's gone. So all of this is going to happen, but cars are a particularly a difficult target. The size of energy, the cycle, the amount of energy that's needed, the amount of power that's needed, the temperature regimes, and the lifetimes we expect are quite large relative to other battery uses.
And I think you made a good point about bringing up the manufacturing challenges. We've had speakers on our panels in the past from the manufacturers saying that it's going to be lithium ion indefinitely just because of the investment that they would have to make a lithium ion battery plant. and the switching over would be challenging. You mentioned lithium metal. Is that a difficult challenge to switch over from a lithium ion plant? And it sounds like a solid state would be a completely different ballgame in terms of manufacturing. Can you talk a little bit about that?
Sure. Well, the innovations in materials for energy storage that can be made in a powder form. So these would be small, actually they're all black, small black powders with a diameter of something like 1/100th of a millimeter, 100th or 10th to 100th of a millimeter. These are processed into the electrodes with things that stick them together and things that help connectivity and things that prevent bad reactions from occurring. As long as what you put into the battery can fit into that modality, then you can change it. So silicon batteries, silicon materials are not purely silicon. They're silicon in different forms that are in powders that contain things like carbon and boron, among other things, that look pretty much like the graphite that goes into the anode right now. So that's amenable to existing manufacturing techniques. On the other side, the cathode, these transition metal oxide-based materials are not going away for a long time. The thing that would replace them would be sulfur, and that requires lithium metal, and that's way down the road. So that cathode will improve because we'll move around the space of those powders. Originally, there was a huge revolution in something called lithium iron phosphate. If you remember a company called A123 that was started in the United States and slowly moved to China, it was involved in making batteries like that. There's more people riding buses running on LFP in China than there are people in the United States. It's a very common battery material. It's used ubiquitously all around. It just doesn't have the energy density we need. Well, the new materials, transition metal oxides, not relatively new, but they're newer than LFP in a commercial sense, are better in terms of energy density. More improvements will be made in terms of safety. So we'll be able to modify that cathode by just changing the nature of that powder, changing the way we make it, making additives. There's also a lot going on in the electrolyte. We don't want to talk about that. To get lithium metal to work would be a partial change in manufacturing. So the cathode would be the same. One side of the peanut butter and jelly sandwich would stay the same. The other side would be radically different. Now it would be some sort of way to have lithium metal form a intimate contact with the electrolyte over and over again, and that would allow you to get the cyclability. There's a lot of work going on doing that. And it turns out that you just can't leave it naked to the electrolyte. Lithium doesn't play well with the electrolytes, so we have to protect it with something. So let's say we can get protected lithium to work. Well, then the next step would be, well, let's get sulfur to work on the other side. So it's a kind of a seesaw progression of advances. We'll move through the battery manufacturing space till a point, let's say, where solid state might be viable with a lithium metal anode and then an all solid state electrolyte and all solid state cathode. So you could envision things moving along. The point at which you would want to go to an all solid state, just the manufacturing is going to be very different. Lithium metal with a conventional cathode, it's sort of half different. But up until that point, lots of innovations are still available to be made that are going to drive the price down. And that's just going to get adopted more and more. It's going to get entrenched. It's going to be harder to get out of the marketplace. So that's going to make a higher barrier for other technologies. And that's also going to push the stationary market. Frankly, again, this is my opinion. I don't see how any technology in 10 years is going to be used in stationary other than lithium ion, just from a cost basis. It's just going to get cheaper and more available.
Very good. Our next speaker, Bill Charmleaf, is currently the director of the Assessment and Standards Division of the US EPA, where he's responsible for developing vehicle engine and fuel environmental air quality regulatory standards for all transportation sources in the US, as well as the development and ongoing improvements to EPA's official air pollution emissions inventory forecasting model for highway and non-road transportation sources. He's worked at the EPA since 1992. During the past 24 years, he's worked on a variety of engine and vehicle emission control programs, including the 2004-2007 Highway Heavy Duty Diesel Standards, EPA's Off-Highway Farm and Construction Tier 4 Diesel Program, greenhouse gas emission standards for light-duty vehicles, covering the model years 2012 to 2025. Welcome, Bill.
Thank you, Bruce. And Bruce, can you just let me know you can hear me? Thumbs up.
I can hear you.
And you guys can, is my presentation up?
It is.
Excellent, thank you. Well, thank you, Bruce, for asking, for reaching out to EPA and asking us to participate today. And I have really enjoyed listening to all the other speakers, including Congresswoman Dingell. I work in her district, but I don't actually live in her district. Again, my name is Bill Charmley, and I work at EPA, usually in Ann Arbor. I live in southern Oakland County here in Michigan. And what I like to do today is cover a few slides about sort of the background of a little bit on the environmental context for light duty vehicles, some history on our greenhouse gas standards, including both on the rulemaking side, but also what have we been seeing in the real world as far as the performance of the firms in the last 10 years. I'll spend a little bit of time talking about the direction that we've received with the new administration from President Biden. And then I'm going to end by going a little bit deep on some of the issues that we're looking into, but certainly not go, I don't have enough time to go too much down that path, but just sort of give an indication of some of the things that we're looking at. So with that, I won't spend too much time on this because I know, I think maybe Gary mentioned this during his presentation, that with respect to light duty vehicles, light duty vehicles are obviously very, very important to the United States, important for jobs and manufacturing, and ultra important for the people, for personal mobility. But as we know, light duty vehicles do have environmental impacts, and both on criteria pollutants and air toxics, as well as on greenhouse gas emissions. And here I'm just showing some data from last year's, what we used to call the Sources and Sinks, EPA's annual report that talks about all of the greenhouse gas sources here in the US. And as Gary mentioned, just in the last few years, the transportation sector is now the largest subsector for the US. Part of me is personally frustrated by that because I spent so much of my career working on it, and all that they had to do for the electric power industry was to have the natural gas boom. And then, because the natural gas boom, moving away from coal, the electric power industry used to be the #1 source, but they've come down much more quickly than transportation. And then within transportation, light duty vehicles is the largest source. It's not quite 2/3, but almost 60%, at least in 2018. This was our estimate from 2018. Just for the most part, I'm going to focus today on our CO2 and greenhouse gas program. So this is just a very brief history of our standard setting under the Biden administration. Under President Obama's administration, we established standards that covered from model year 2012 all the way up through 2025. We did that in 2 regulatory actions. One we finalized in 2010 and the other in 2012. Those regulatory programs were coordinated with our colleagues at the Department of Transportation. EPA's responsibility is for public health and welfare, and our regulatory authority is for setting emission standards. So we established greenhouse gas standards, meaning CO2 standards and N2O and methane standards. For DOT, their regulatory authority comes from bills that Congress passed first back in 1975, and their responsibility is for setting fuel economy standards. So we did joint actions to try to have the programs aligned and be, I would say, responsive to the administration's overall goals at the time. And we actually revisited those once under the President Obama's administration in something we called a midterm evaluation that we did in 2016 and early 2017, where we looked once again at the standards out through 2025. And then under the previous administration, of President Trump's administration, where, as I think we know, one of the major sort of public policy messages from President Trump was deregulatory. And so EPA and DOT went through an effort to relook at the standards for light duty vehicles, including the greenhouse gas standards and the CAFE standards. And we issued a rulemaking just last year in 2020 that significantly relaxed the previous EPA standards and then extended them out one more year. And that rulemaking was called the Safer, Affordable, Fuel Efficient Vehicle Rule. So the Trump administration called it the SAFE Rule. As I mentioned, I also wanted to talk a little bit about, well, what have we been seeing in the last, now this goes all the way back to 1975, but what have we been seeing in the last approximately 10 years since we've had the greenhouse gas standards, EPA standards for vehicles. And what we've seen is in the last 10 years in general, very good positive trends in the real world with respect to the new vehicle fleet of, in general, year-over-year improvements of what people are buying as far as fuel economy, and the same thing with respect to greenhouse gas CO2 emissions. That was for the whole industry sort of sales weighted. I think some of the progress that the companies have been making has been a little bit offset by the shift from consumers from passenger cars to light trucks. This slide is showing that really, when you look at any individual subsector, and we have these 5 categories of sedans, wagons, car, and then truck SUVs, minivans, and pickup trucks, the trajectory for the last almost 10 years now has been very, very positive. Consumers have access to and are buying vehicles that in general, on average, are better than the ones from the year before. And so for almost every single one of these major subcategories, 2019, I think, was a record as far as, the overall sales weighted fuel economy and also CO2. But as I mentioned, part of that has been offset because of the large shift between cars and trucks, so certainly starting in like that 2014 timeframe. And I'll come back to that topic at the end. This slide is the one slide I have regarding what we call the compliance with the CO2 standards, meaning how are individual companies and then how is the industry as a whole doing. Again, the first EPA standards went in place back in from year 2012. And what we saw for the first 4 years of the program was a very large overcompliance on average for the industry. Each individual company was maybe a little bit different, but on aggregate, a large overcompliance. And then what we've seen for the last 4 years, including 2019, is each year with respect to the sort of industry targets and individual companies' targets, on average, the industry has been falling short of the targets. They've been improving each year, so the performance has been getting better. And especially when you take out the car truck, as I mentioned before, each segment is generally getting better, but not enough to keep up with the standards. And so that's what the right hand is showing is one way to look at this is to look at the industry-wide credit bank. And what you can see is for the first 4 years, the blue bars on the right-hand side is on average, the industry was banking credits outperforming the standards. And then you can see since 2016, each year falling again on average, not each company was doing this, but on average, falling a little bit short. And so using some of the banked credits as well as their actual improvement in the CO2 performance to comply with the standards. Now I'm going to transition to, the direction that we've received from the new administration. On his first day in office, President Biden signed an executive order that covered a whole bunch of different topics related to climate change and the environment and public health. So the executive order is much, much longer than the one sentence that I put in here. But among the request or direction from the president was a direction to both EPA and the DOT to revisit the standards that were established by the Trump administration in 2020. And specifically, EPA and DOT were directed to consider undertaking a new rulemaking effort to consider suspending, revising, or rescinding. In this case, we're looking at the topic of revising the standards that were set the previous year. And the president directed the agencies to work towards issuing a proposal no later than the end of July of this year. So that's one of the major projects that we're working on right now. Some context for the rulemaking that we're working on right now, I think that's very important. Three things that I'll talk about. One is since in the last few years, when it became clear under President Trump's deregulatory agenda that we were going to be reducing the stringency of the greenhouse gas standards, the state of California, who also has greenhouse gas standards and had adopted EPA's standards back in 2012, went down a path of working with a number of the auto companies to sign voluntary agreements. And so they call it the California Framework Agreement. And the interesting thing about these agreements were that they were commitments by each of these auto companies about what would be the performance of their fleet across the entire country. So not just what they sell in California, which is traditionally how California has done standards. These voluntary agreements were commitments by these firms to basically over comply with the compared to the Trump administration standards and meet more stringent standards at the national level for 21 through 2026. And this is important background and context for EPA as we think about revising the standards, because among other things, it indicates that that at least some elements of the industry are certainly capable of doing more than the standards that were established last year in the SAFE rulemaking. Another really important context for the rulemaking that we're working on now, and Gary talked about this quite a bit, and of course it was the majority of Peter's discussion about electrification. And my main point here is that when we first worked on these standards back in 2012, really at that point in time, for the most part, it was just the Chevy Volt and the Nissan Leaf that were just being introduced into the market. And even, I would say, 2 and 3 years ago, while we knew that more and more electrification was coming, we have really seen, like we call it, a flurry of announcements from auto companies, from the global auto companies, and of course the US companies as well, about their massive plans for investment in electrification and for bringing new products to the market. And so that is an important context, even for rulemaking where we're maybe only looking at to revise standards through 2026, because it's right in the middle of this transition that the industry is going down. And the last part I already mentioned before, important context for the EPA rulemaking activity is that we're doing this coordinated with a effort by DOT to do the same thing with respect to the CAFE standard. So it's certainly a lot of discussion and coordination among the two agencies. Here I just wanted to provide a little bit more visual of, well, what are some of these already known programs? So just showing, this is just covering 2020 through 2026, a projection of what is already known of programs that are available. The most stringent program on this graph is the standards that were established and adopted by EPA under President Obama back in 2012, and showing what the progression of those standards were sort of year over year at the fleet-wide level in grams per mile of CO2. And then you could see the gray line at the top was what the standards are that we finalized last year. When EPA revised these standards and revisited them, we issued a final rulemaking under President Trump's administration I think in April of last year of 2020, and basically relaxing the standards. There's still year over year improvements, but significantly lower in stringency than what was done back in 2012. And then I just mentioned the California framework. The California framework, as I said, was an agreement for a voluntary agreement between 5 companies in the state of California, but an agreement for what type of emission levels they would commit to for CO2 through their national sales. And you can see it's basically not exactly halfway, but kind of halfway between the the old EPA standards, the Obama standards, and the new revised safe standards. So as I mentioned, what we're working on right now at EPA in the very near term is this near-term rulemaking, a proposal to revise the safe standards. We're going to, at a minimum, propose standards to revise standards through 2026, because that's in essence what the executive order directed the agency to do. And of course, we're looking forward to continuing to work with stakeholders as we both develop the July proposal, and then after the proposal, the EPA and DOT proposal, there'll be public comment period, and then both agencies will begin working on final rulemaking to make decisions on where to land for these revised standards. I would say in parallel, certainly within EPA, we are looking at what are the other opportunities to go beyond 2026. Gary had mentioned the enormous importance of lead time for the auto industry. When we first established the 2025 standards back in 2012, right, we were providing 13 to 14 years for the auto industry to know the targets that they're going to have to meet, which is incredibly valuable for a massively capital intensive industry, and an industry where it takes 4 to 5 years once you know the technology to actually take it into large scale production in an auto plant. And so we are thinking about where we might want to go beyond 2026, and we'll be working with the administration on that. And it's quite possible that could go beyond just our revised greenhouse gas standards, but also taking a look at our current criteria pollutant standards. Is there need for further improvement there? As I mentioned, and I'm not going to go into any detail on this, but our group in Ann Arbor with an EPA, we are continuing to perform a whole range of different types of technical research and investigation to help provide technical support for the policies of any given administration, including the current administration. And just listing here some of the work that we're doing, it's part of the reason why we're very excited to look at this new report that the National Academy of Science that put out, because it can help provide us both new information, but also help guide our own work about where we should be putting our efforts. And these are some of the areas that we're investing in now on, cost estimation for technologies, benchmarking of technologies, looking at modeling tools to help make future projections, looking at economic and consumer research, and also a number of my staff and managers spend some amount of time through some of the international UN processes of coordinating with some of our colleagues around the world on different areas of both research and learning more about where they're headed. So I have about 3 minutes left in my presentation for my 20 minutes. And I wanted to tee up just one issue of, when we think not so much about this near-term rule that we're going to propose in July, but when we think about where to go beyond 2026, we also want to think very carefully about, we came up with the overall structure of this program, not the standards necessarily, but the structure way back in 2009 and 2010, before we'd ever implemented greenhouse gas standards. And now we have, as I mentioned, about 10 years of experience of implementing it, doing compliance, doing enforcement, working with the industry, understanding how the industry responds. And so we also feel like a longer term action is an opportunity to see if there's any things that we might want to revisit about how the program works, especially in light of some of the changes that we're seeing in the industry. And there's a whole range of things that we might want to take another look at. But one of the things that we've certainly been trying to understand is what has been the impact of the change in what consumers want, the shift from cars to trucks. So I got just a few slides on this, on one topic that we're spending some time on now, again, to think about potential changes for the long term. So this slide is just showing this enormous trend and shift between passenger cars and two crossovers and SUVs and light trucks that we've seen in the last basically 10 years, but certainly accelerated a lot since 2014, and showing basically the reversal where the passenger car market has shrunk quite a bit, whereas the light truck, SUV and crossover market has increased quite a bit. This is a little bit more detailed, just showing the same kind of thing from EPA's annual trends report, showing that compared to way back in 2012, when we set originally the 2025 standards, these very large scale shifts of reductions in passenger cars and large increase in especially the truck size SUVs, but pickup trucks as well. We spent some time, this slide is showing what has been the impact of that on the actual standards compared to what we predicted. So the orange line at the top is the industry-wide effective passenger car standard. I'm sorry, the truck standard. The blue line at the bottom, because this is in gram per mile space, right? So the lower number is more stringent. It's showing what's happened to the passenger car standard as year over year, the standard gets a little bit more stringent. And then the black line is not a standard, it's our sales weighting of the two. And what we are showing here is that because of the shift, consumer preferences from passenger cars to trucks, how much CO2 on a gram per mile basis are we higher than what we thought we were going to be back in 2012. And at the fleet-wide level, it's about 16 gram per mile higher than what we had originally predicted. But that was part of the design of the program, was to allow for consumer choice. So, you know, it just happens to be this is where consumers have gone. But the one thing that we have looked into even more deeply is understanding, as I mentioned, a lot of, excuse me. A lot of the shifts that we have seen have been from what are classified as two-wheel drive passenger cars to four-wheel drive light trucks. But in essence, what we're really talking about here is we did a deep dive on vehicles that are in essence crossover vehicles or small SUVs that are the same vehicle other than one is two-wheel drive and one is four-wheel drive. And so if it's a two-wheel drive, it has to comply with our passenger car standards. And if it's a four-wheel drive, it has to comply with the light truck standards, which is a lower level of stringency. And so we did an analysis of the 2019 fleet to see, we looked at 32 unique models, so where we had pairs. And I don't know if this is an example of actual one, but something where maybe it was the Ford Escape, the two-wheel drive version and the four-wheel drive version, or all their variants from companies where the two are the same products, but largely the only difference was two-wheel drive versus four-wheel drive. And we know that four-wheel drive products take more energy. And so when we actually looked at the data, it showed us that the difference between two basically identical vehicles other than the driveline was 15 grams per mile. But when we actually look at what our standards allow for, the standards actually are 48 gram per mile less stringent. And so what we're looking at carefully is for the long term of the program, looking back at the analysis we did back in 2010 and 11, 12 timeframe, and understand, well, why did we think that these vehicles were going to be 48 grams per mile higher, the four-wheel drive version, but in reality, they're only 15 gram per mile? And what kind of incentive is that providing? Whereas our standards are supposed to be generally physics-based and neutral between passenger cars and trucks. We want them to have similar levels of technology, but allow consumers to buy what they would like. And so this is an area where we want to look carefully at and say, now that we have the opportunity, the benefit to look back over the last 10 years and maybe design a program for the long term out into the future, this would be one example of an area that is probably worth revisiting. And we have, I would say, a short list of other topics like that for the long term. I think that this is my last slide. And so, again, I wanted to just say really appreciate the invitation for the conference today. And we're looking forward to engaging with all the stakeholders as we design both this near-term rulemaking the president has set us down the path of, as well as we think about where to go beyond 2026.
Thank you very much, Bill. We've got some questions for you. Generally, your description of the 44 versus 56% sales split, usually we hear about it as being like a 30 to 70% sales split. Is that because people are not taking into account the way that some of the crossovers are treated as SUVs, some of them as passenger cars?
Yeah, that's right. It's just that simple. It depends on what kind of definitions you're using. And I was talking about our regulatory definitions. And under our regulatory definitions, most smaller two-wheel drive SUVs are categorized as passenger cars. That's all.
Okay. How long will it take for any changes that you're going to make into the SAFE program to actually be put in place? During the previous administration, took about 3 years. Same type of time frame for this?
No, I don't think it will take us very long at all, in part because after you do the exact same project 3 or 4 times in 10 years, you start to get really good at it. And so, and that's pretty much what we've done. We've relooked at this issue multiple times the last couple of years. So, you know, I would say, and plus President Biden has put us on a schedule. He has said, thou must issue a proposal by July. So we're going to issue a proposal by July. And I think I wouldn't be surprised at all if we're able to issue a final rulemaking by the end of this calendar year.
And is this for emissions or fuel economy and emissions, or just fuel economy?
Well, I don't, those terms are confusing me a little bit. Everything that we do at EPA is emissions.
Yeah.
And we don't do anything with fuel economy. So
Right.
what I was talking about was our greenhouse gas
Yeah.
revision of the safe greenhouse gas standards. That's what the president has ordered, that we issue a proposal to revise those by this summer, by the end of July. And I would say that while we don't have a firm schedule, I wouldn't be surprised if we issue a final rulemaking by the end of this calendar year.
Right. Now, one of the things that happened in the previous administration was the kind of a decoupling for the fuel economy story between EPA and NHTSA. Are they now coupling again? Is EPA and NHTSA coupling again?
Well, even under the previous administration, right, the two programs, as far as through the regulations, each respective regulations, right, were very similar, meaning that the relaxation was to about 1.5% per year. And so the CAFE standards now march down year over year at that rate, and the EPA standards are at that rate. But at least with respect to, you know, the work that we're doing now, I'd say that there's certainly a lot of coordination between EPA and DOT. And as I mentioned, you know, President Biden's executive order was not specific to only the EPA greenhouse gas standards. It was basically directing EPA and DOT to issue revisions under our authority no later than July. So under the authority for DOT, they will do that also by the end of July for the CAFE standards.
Very good. Okay, thank you. One of our attendees said, do you see a shift towards classifying or separating ICE vehicle targets from BEVs? Will there be separate targets for the fleet?
Certainly that's something that some of the stakeholders have talked about, you know, about, you know, if there's going to be more and more movement to EVs or zero emission vehicles, should EPA consider having targets specifically for ICE and targets specifically for ZEV? So I wouldn't want to rule it out, but that is not what we historically have done. We have performance-based standards, both for criteria pollutants, you know, topics like hydrocarbons and NOx and VOCs, as well as for greenhouse gas emissions. I would say that we certainly have the authority to do something like that, because the Clean Air Act provides the agency the authority to categorize and set standards for classes and categories. So there could be different ways of doing it. But certainly I would say for this near-term action of revising, once again, the standards through 2025, I don't think that that's a leading candidate for how to do it.
Okay. Now, one of the questions that I spoke earlier about is, what do we really need fuel economy standards as opposed to just emission standards? The Europeans don't have fuel economy standards, I don't think. It's just emission standards to manage everything. Is this, what's your opinion about the the need for fuel economy standards if we're really just focusing on emissions?
Well, at EPA, my team and I, we work on a lot of different projects over the years. And one thing that we don't usually question is when Congress tells us to do something. I don't really want to work on the Renewable Fuel Standards Program, but that is what the law of the land is, and they have directed EPA to do that. Yeah. So I'm using it as a background for saying Congress has directed EPA through the Clean Air Act to protect public health and welfare from air pollution, including from mobile sources in cars. So that is part of our mission, to work on reducing the environmental impact on public health and welfare from emissions of cars. Congress also directed DOT back in 1975, and then they revisited this issue, I think in 2007, of saying that it is the responsibility of DOT and HTSA to establish fuel economy and CAFE standards to address energy independence. And so as career folks in federal agencies, we are generally taught not to do things different from what Congress directs us to enact. So if this is what Congress has directed, have two different statutes for two different agencies for similar purposes, but they are not identical purposes. Right. That seems reasonable to me.
Right. Right. What was the historically, what was the thinking, Congress's thinking back in the 70s when they created the two separate groups? I mean, the emissions versus fuel economy.
Well,
probably some historical press.
I was going to say in 1975, I was probably I think I was in kindergarten. So I'm not 100% certain, but certainly enough to know because of the oil embargo, right?
Yeah.
Because of the oil embargo of 1975. And then also what happened, that Congress passed the Energy Policy Conservation Act and established the fuel economy CAFE standards. Mm-hmm. And certainly the auto industry itself, as well as I think Congresswoman Dignall's husband and the Michigan delegation at that point in time, it was known that there were safety implications from some approaches for reducing fuel economy. So Congress decided to give that program a standard setting authority to DOT and the National Highway Traffic Safety Administration.
Very good. Michael, you've been working in this area for a long time. Is that your understanding of how it played out back in the 70s?
Yeah, I think I'm in the same boat as Bill, but I think I'm even a little bit less well-developed in the 1975 time period. But yeah, that's my understanding also. I mean, the perspective back in the 70s was energy conservation. We were looking at it the lens of oil embargoes and long lines at gas stations, things of that nature. And as Bill said, I think DOT and NHTSA was given the authority to set those fuel economy regulations, recognizing the potential safety implications of certain pathways for improving fuel economy.
Okay, very good. Thank you. Bill, I think you talked a little bit about the real world testing, driving. Will the real world driving testing make it harder for manufacturers to meet their fuel economy improvement goals?
So I would guess that the question is asking about some of the standard setting approaches that our colleagues in Europe have adopted, called, I think it's called RDE, real driving emissions, or something like that. Yeah. And so primarily that has been focused on criteria pollutants. Because, right, with criteria pollutants and with catalysts, right, if you if you don't use the catalytic converter on a car, you can have like a 3 or 4 orders of magnitude change in emissions, right? You can increase emissions by well over 100 times. That doesn't happen for fuel economy. And so first of all, we don't currently for light duty, we have some programs for on-highway heavy duty that require on-road testing and for NOx and particulate matter and to comply with an on-road standard.
Mhm.
We do not currently have that for light duty vehicles. It certainly is something because of the work that the Europeans have done that we have looked at over the years. And maybe that could be a direction that we go in the future. But I think that most of the motivation for something like that would actually not be CO2 emissions. I think it's, as I mentioned, it's more motivated to make sure that for calibration and catalyst design, that we have good control for criteria pollutants in the real world.
Very good. Thank you. I think we're now caught up on our timing, and I think that you're off the hook, Bill, for the moment. Thank you very much for your presentation. I thought you gave some really good insights and into looking some of the issues, especially the split between passenger cars and light trucks that we've been seeing over the last few years, and the work that you guys have been looking at there. Our next speaker, Mike Hartrick, joined the Alliance for Automotive Innovation at its inception, coming from the Alliance for Automotive Manufacturers, which he joined in 2016. Among other topics, he covers greenhouse gas, fuel economy regulations, and vehicle certification issues. He brings over 20 years of automotive industry experience to auto innovators, including 16 plus years at FCA and its predecessors. His experience includes 12 years in rulemaking and compliance planning for the U.S. light-duty vehicle greenhouse gas, fuel economy, and zero-emission vehicle regulations. He holds a bachelor's degree in science in chemical engineering from Michigan Technological University. Michael, thank you for joining us.
Yeah, thank you for having me, Bruce. Make sure my presentation is showing here properly. Is everybody able to see it?
You are up.
Thank you. It's not always easy to tell here. So before I get going, I'd like to thank my other co-presenters here. They did such a nice job of setting up the things I want to speak about today. So it worked out really well. I didn't know I was going to be at the very end of the program until a couple of days ago, and we didn't really coordinate the presentation, so to speak. But I think the move from this morning, Debbie Dingell's remarks in particular, and kind of Bill Charmley's walk through what's happening here in the near term, do a nice job of getting us to the point of where I'm going to start today. So maybe a little bit of a historical perspective too, that for a long time, people have liked to characterize these environmental issues as industry versus the environment. You have to pick and choose a winner, and I don't think we're really there anymore. And especially from like the auto industry perspective, we're talking right now more about coordination and cooperation and a commitment to transition to net zero emission vehicles. So, I would say that we're in a much more proactive and future-looking state than we were historically. And I'm really happy to be working for an organization that's taking that perspective, and the automakers that are supporting us. Just kind of to building on what Bill Charmley said a few minutes ago, we really look forward to working with EPA to look at getting through kind of these near-term challenges. What do we do through 2026? But my perspective today is actually going to focus on a little bit longer term, kind of past 2026. But recognizing that to get past 2026 and to do the things that we need to do in that time frame, out through into the 2030s, we're going to have to start taking a lot of actions today. Be they legislative, regulatory, and as manufacturers, developing the vehicles and the like that will support these transitions into the future. So with that, let me jump into my presentation, and thank you again, everybody. This working here. Why am I not changing? There we go. Okay. So I think this is actually the first time that the Alliance for Automotive Innovation has presented to an Auto Futures conference. So if you'll forgive me, I'd like to speak just very briefly about the organization. So again, we are the Alliance for Automotive Innovation. We call ourselves Auto Innovators for short. In 2020, we're still a relatively new organization. So we actually formed this organization in January of 2020, essentially merging the two predecessor light-duty vehicle trade associations, the Alliance of Automobile Manufacturers and the Association of Global Automakers. By sales in the United States, we represent about 99% of light-duty vehicle manufacturers. We also include value chain supplier partners in our membership and automotive technology companies that are, looking to be part of this transition of the future of cleaner, safer, and smarter automobiles. We currently have about 38 members, and if you're interested in learning more about our organization or membership in it, you can visit our website at autosinnovate.org. So I did mention our vision here is cleaner, safer, and smarter vehicles. We're really on the cusp of what will likely be the most transformative period in the history of the automotive industry in the United States. So through substantial long-term investments in electrification, as well as advanced safety technologies, including automation, the industry is committed to creating a cleaner, safer, and smarter future for personal mobility. Due to intense global competition, the U.S. must recommit itself to developing these innovative technologies supported by complementary legislative and regulatory policies that will redefine motor vehicle transportation for decades. This is what is at stake as we look to the future of the auto industry in the U.S. The nations that lead the development and adoption of innovative technologies such as electrification, connectivity, and automation will also shape supply chains, define global standards, and potentially reshape the international marketplace. This isn't just about the future of the auto industry in the U.S. It's about the nation's global competitiveness and economic security. So let me provide a little bit of the political backdrop that, as we see it as going into this year here. So first of all, the automotive policy prism. This conference is addressing the topic of the new role of government in the automotive industry. Our expectation is that the Biden administration will address this role through a multifaceted and overlapping lens of climate, economic, and other policies. Regarding climate, the new administration is taking a whole government focus, coordinating across multiple agencies. And this is probably one of the biggest differences we see to some prior administrations that have looked at, climate as an issue to address. But this is probably the first administration that I've been involved with that really is trying to look at climate change across all of the various parts of government. So in tandem, the administration is also dealing with economic fallout from a global pandemic and is expected to use climate policies to drive U.S. investment and job creation, which will help us, I think, as an industry to move forward with this transformation. Other important themes include social justice and equity that are probably going to be playing a larger role, and especially how environmental regulations are developed and implemented. And then, kind of building on where this all goes in the legislative front, right now there's a Democratic majority in both the House and Senate, albeit very slim, where multiple climate and economic related packages are on the table, including transportation and infrastructure. So today I'm going to focus discussions on the transformation to net zero emission light duty vehicles. That doesn't mean that we think that the transitions to autonomous and connected vehicles and safety or any of that else is less important. It's just I need to focus on only one of these topics given the time we have together today. So recently, President Biden laid out a almost $2.25 trillion American jobs plan. He's also, even more recently than that, started laying out budget priorities. But this American jobs plan that he's talking about provides about $174 billion to support electric vehicles, assuming, of course, that supporting legislation is passed. But these are the goals of the Biden administration itself. So this American jobs plan is going to promote many of the features that auto innovators right now is advocating for in support of this transition to a net zero emission future for cars. The bill provides, or the plan would provide direct support for electric vehicles in addition to other items related to automobiles. For example, for the electric vehicles, media has reported that there's $100 billion in new EV consumer rebates that are being talked about, $15 billion to build 500,000 EV charging stations, and then a number of these other cost outlays to also support the things that the auto industry is interested in. So we look forward to working with the legislators and on transportation, infrastructure, and jobs as these bills are developed. So let me take some time here first before I jump into kind of the future and what we're advocating for. Where is the auto industry right now, and where are we headed? And I think for many people on this at this conference, it's not going to be a surprise, many of the things I'm saying, but hopefully I bring them into a little bit sharper focus for all of you. So first of all, a lot of automakers' announcements, goals, and aspirations here. And I won't try to read the words on the slide. Of course, I think you're going to get a copy after this is all done, and you can feel free to read these yourselves. But there have been a lot of automotive manufacturers announcing commitments to working towards a net zero carbon transportation future that includes a shift to electric drive vehicles. Recently, it seems like no more than a couple of weeks go by without a new announcement on these types of commitments. You know, by some estimates, by 2023, automakers and suppliers are expected to invest $250 billion in electrification and R&D, you know, over the past couple of years leading into that 2023 time period. And multiple manufacturers have now stated their aspirations to shift their fleets to 100% electric or electrified vehicles, with interim goals for certain brands to hit those milestones even earlier. In the longer term, companies have also committed to set goals for carbon neutrality and reducing vehicle emissions 90% or more. And for some of these companies, these goals aren't always completely clear how they're stated, but some companies have been pretty clear that their goals include that 90% reduction, or that carbon neutrality goal is including vehicles on the road, their vehicles that are already on the road. So that's a pretty big stretch goal, you know, considering I think, as Peter mentioned, that the half-life of vehicles is roughly 15 years, or at minimum, you know, we think that, you know, these vehicle cycles move in these 10 to 15 year cycles. As we currently stand today, I don't think it's a surprise to anybody that U.S. ZEV sales remain low. For the country as a whole, the U.S. is still floating around the 2 to 3% sales rate of zero-emission vehicles, including battery electric vehicles and plug-in hybrid electric vehicles. But there's a lot of anticipated growth. So this data comes from IHS Markit. This is a purchase data set that I've done my own analysis of, trying to figure out what IHS is projecting for new vehicle market share and the number of nameplates of electric vehicles. So there's a lot of significant market growth projected over the next, call it 5 to 6 years from where we are today. And by 2027, new vehicle market share for electric vehicles, or electrified vehicles, maybe I should say, since I'm including plug-in hybrids and fuel cell electric vehicles, is expected to grow to about 15% in the US. Similarly, the number of plug-in electric and fuel cell nameplates is expected to grow from about 50 today to over 300 in 2027. What's not as clear, you know, looking at the news and looking at all the things that have to happen, is whether the projections such as this underestimate where the market will be in the next several years, given the challenges and knowing the long-term trends here of where people want this market to go, or whether these estimates, you know, provided by third parties are overestimating what can be achieved in the U.S. market through U.S. supply chains. What is clear is that even growth to the roughly 15% level will require commitment from manufacturers and government, and a significant shift in consumer attitudes about electric vehicles. Excuse me for 1 second. The dog scratches here behind me. Thank you. Sorry about that. So right now, the current trajectory is not really sufficient to meet the goal. So what I've done here is, even with showing these large increases in market share and available models anticipated over the next several years, ZEV market penetration and market readiness is only a shadow of what it will need to be in order to meet various state and federal goals. A number of states have adopted goals to achieve 100% sales of new ZEV models by 2035, with others talking about achieving that goal even more quickly. Other national and subnational governments have discussed complete vehicle electrification, or at least net zero emissions, as necessary to meet international climate goals. Even coming close to such goals would require achieving almost 100% ZEV sales no later than 2040 to allow time for the vehicle fleet to turn over to zero emission vehicles. What I've plotted here are a couple of scenarios from the 2020 ZEV market penetration level up to the 100% new vehicle market penetration. And there's really nothing particular in this analysis. I didn't try to account for real market conditions or anything like that. These are just hypothetical growth rates that get you to 100% ZEVs by 2035 to 2040. So first, I plot linear growth to 100% in 2035 to 2040 from today's levels, and show that that greatly exceeds even the projected market over the next couple of years. The second, which maybe is a little bit more in keeping with a traditional S-curve type adoption rate, even though I've saved myself the trouble and done this more as an exponential, is to use a consistent compound average growth rate from the 2020 level. You can see that's maybe at least a little bit more in line with these IHS market projections, but still there's a really large gap, in the late 2020s and into the 2030s of how do you get from kind of these levels of projections to that 100% level here. So my intent here isn't to conclude what the ZEV market growth may look like in the future, but to demonstrate that there is a large gap to cover before we can meet various goals and relatively little time to do so. I've been on calls with regulators and legislators, and one of the things that I've heard is, the last half of the decade, it may seem kind of far away. We might talk about it in the long-term perspective, but really that's just around the corner given the typical auto industry development cycles. So developing a comprehensive strategy to close this gap is going to require commitment from all stakeholders to create the conditions that may enable such market growth. A little bit more information about public charging needs here. So in the last couple of days, Atlas Public Policy published a report called U.S. Passenger Vehicle Electrification Infrastructure Assessment, Results for Light-Duty Vehicle Charging. So this was April 8th, so I guess that means less than a week ago. And I thought some of these slides were really interesting as they compare to what I was just showing on the electric vehicles themselves. So this is kind of maybe the other half of the equation on the fueling side. So similar challenges are expected for supporting refueling infrastructure. This analysis projects a need for $39 billion for public charging by 2030, in addition to costs to install infrastructure at residences. And that funding level of $39 billion is nowhere near the committed funding to try to achieve those types of goals is nowhere near that $39 billion right now. So right here, this Atlas Public Policy report estimates about $2.6 billion approved from utilities, another $1.2 billion coming from the Electrify America part of the VW settlement agreement, another $700 million or so that's already committed by states, and that gets you to about $4.5 billion out of the $39 billion that are estimated as needed by this particular analysis. And I'm not trying to oversell this particular analysis. It just was convenient to the topic today. But we can talk about are the numbers exactly right or not, but I think that the point still remains that there's a huge gap between committed funding and the funding that will be needed just to even support infrastructure. So why is government engagement critical now? So kind of thinking about today's topic as I was preparing, I had to think about what's different now than in the past, trying to stick with this theme of the new role of government in the auto industry. So from a historical perspective, the government has always played a strong role in the automotive industry, particularly in the form of regulation. Bill, I think, mentioned that the government's been regulating emissions and energy use of automobiles since the 1970s, and they started regulating safety even earlier than that. EPA, CARB, and the Department of Transportation have extensive experience in this type of government engagement, supply-side requirements for the industry to improve when market forces alone were insufficient to drive the policy goals. Regulation is typically taken an evolutionary approach, although there are several examples such as the California ZEV mandate that focused on technology innovation and market development. Market innovations, on the other hand, have typically been more limited and focused on encouraging either more knowledge of a favored attribute, for example, fueleconomy.gov, And in the case of some advanced technologies, incentives to drive early adoption, the example that Debbie Dingle provided earlier this morning about the tax incentives. So how are things really changing now? So I would argue that the biggest difference that we're looking at now and why government engagement is so critical at this time is the speed of the desired transformation. As opposed to the evolutionary changes that regulations have driven in the past, we're talking about a revolutionary transformation. So this rapid transformation to a net zero future requires coordinated and supporting policies. And traditional regulation alone is poorly equipped to make that speed of change. The reason for that is that a revolutionary high-speed transformation of this type requires more than just a technology change. It requires changes outside of the control of the regulated industry, in other words, us, the automakers, to occur at the same time in a supportive manner. For example, vehicles and infrastructure must arrive together. They support each other. You can't build a lot of infrastructure and have it just sitting around doing nothing and not making money for the people that invested in it. They want the cars, the infrastructure, all of it has to arrive together. Similarly, market supply and demand must grow together. Manufacturers will be seeking a return on the massive investments that they are making, and the market demand must match that supply and vice versa. If we don't supply enough of the vehicles that the consumers desire, then they're either not going to buy the vehicles because they're not what they're looking for, or we're going to have an undersupply of the technology that's needed and desired, and vice versa. If we don't have that people looking to actually buy the vehicles, and I can't remember who mentioned it earlier, but if they're not there trying to buy the vehicles, manufacturers are stuck with vehicles that they can't sell, or they have to reduce the volume, and therefore their ability to stay in business. So a quick look at what comprehensive and consistent policy support can do. And although we're still at a relatively low rate of penetration even in California, I wanted to show that based on our experience out there in California, we know that a comprehensive and consistent policy support can make a very large difference in electric vehicle adoption. California first adopted a comprehensive ZEV action plan in 2013. That action plan has been updated numerous times, and activities have grown to encompass a broad range of California agencies. We estimate that California alone will have spent $3.5 billion state dollars on its EV market by 2025, based on over $1 billion in purchase incentives and government commitments on infrastructure. This doesn't include additional funds from the Public Utility Commission, multiple other agency resources in the state, various consumer awareness campaigns, funds from the low carbon fuel standard in California, and other activities encouraging ZEV market growth. By 2020, California's ZEV market share had grown to almost 8%, or about 4 times higher than the US overall, and 3.5 times even that of other states that are currently enforcing California's zero-emission vehicle mandate regulations. It's not only regulation alone that has caused ZEV market growth in California, it's also all of these supportive policies, and we can see how that has made a difference there. So a few words about our recent advocacy and what we're advocating for as an auto industry. First, we see we are advocating for similar national level approaches to support and encourage a growing share of zero emission vehicles sales in the US, kind of like what we're seeing in California. Auto Innovators recently sent a letter to President Biden which focuses on 3 key areas: affordability and awareness for consumers, electric charging and hydrogen refueling infrastructure, and innovation, manufacturing, and supply chain policies. So I don't know if Congresswoman Dingle picked up some of these ideas from our letter, and I'd love to think that we're having that sort of influence, or if this is some of the things that she talked about this morning are things that she's coming up on her own, listening to various stakeholders. But kind of thinking back to this morning, I'm really kind of pleased that we are in such a close alignment on what we think the 3 critical things are to keeping this market moving forward. So let me talk a little bit more about some of the specifics here. First of all, consumers, affordability, and awareness. We're supporting policies to improve affordability and awareness. Although great progress has been made on battery and other costs, upfront costs for zero-emission vehicles remain higher than their ICE counterparts. Recently, as Gary talked about this morning, The National Academies of Sciences released their report on fuel economy through 2035. In that report, the National Academies estimated that BEVs will not reach cost parity until 2023 to 2030, depending on vehicle type and operating range. To help bridge this divide, we're supporting federal tax credits, plug-in and fuel cell vehicles, prioritization of R&D funding on batteries, fuel cells, and hydrogen fuel generation, development and funding of programs to expand consumer awareness of ZEVs and the availability of refueling infrastructure, and asking for federal and state governments to increase use and awareness of ZEVs through adoption in government fleets. Regarding charging and refueling infrastructure, we also need to look at addressing other things, other things outside of just cost. That includes convenience parity and range anxiety concerns from customers. Policies will need to support charging at home, whether it is a private residence or a multifamily dwelling. All stakeholders must work together on public policy efforts such as federal tax incentives, grants, rebates, and other mechanisms to spur significant refueling infrastructure development in 3 key areas: homes, workplaces, and highway and other public locations. Potential supportive policies include tax credits for charging and fueling infrastructure and grants for the development of public infrastructure. We also see the need for developing model building codes that will provide clear direction for new construction and renovations. If we don't make our buildings ready for electric vehicles now when they're being built, or retrofitted when it's convenient to make changes, future installations are likely to be at much higher costs. We also think it's important to consider implications to the electrical grid and to address any risks that others more expert in those areas see as happening. There's a number of different ways that we can see that happening in legislation. Things like the 30C federal tax credit for alternative fuel vehicle refueling properties, the 30D tax incentives, grant programs to allow states to update state energy transportation plans, and committing substantial resources such as a federal rebate program for charger installations or hydrogen refueling infrastructure at workplaces, multi-unit dwellings, and in underserved and disadvantaged communities. There are a number of other ideas we also have, and we can share those offline if desired. Finally, the innovative manufacturing supply chain. While the demand side solutions outlined previously can help address near-term challenges, and they will contribute to sustained U.S. leadership in automotive, but they will contribute to sustained U.S. leadership in automotive innovation only if they are aligned with supply side realities. Vital aspects of the EV supply chain require the manufacturing of batteries, including critical minerals extraction, processing, battery cell production, and end-of-life recycling, and the development and production of fuel cell stacks. In 2019, Chinese chemical companies accounted for roughly 80% of the world's total output of advanced battery raw materials. In fact, the supply side represents one of the best opportunities to develop long-term and sustainable U.S. leadership through manufacturing investments. The U.S. has a number of programs which encourage domestic investments. These should be extended and expanded to encourage and build investments for electric and hydrogen vehicles, including programs like the Advanced Technology Vehicle Manufacturing Program mentioned by Congressman Dingell this morning, or Congresswoman Dingell, excuse me, this morning. Before I close today, I wanted to talk a little bit about potential guideposts for regulation, and these are more in terms of the long-term regulatory perspective as opposed to the near-term perspective that Bill was talking about a few minutes ago. We recognize that regulation will continue to play a role in the transformation to a net zero emissions future. Without dwelling on specifics, there are a number of potential guideposts that I'd like to offer for consideration, including coordination, prioritization, and flexibility. For coordination, we see the need for coordination across governments. Regulations are most efficient when they are coordinated between the agencies. This includes state-federal coordination, federal-to-federal agency coordination, and coordination between regulations and legislation. Maybe one of the most important things I think we need to remember is this isn't a race to zero with every agency trying to outdo the next. It's not about who can regulate this first. For states, we need to recognize unique conditions both between states and even within states of what the supportive policies are and the market readiness for these vehicles. Between federal agencies and between the federal and state agencies, we'd like to see an avoidance of duplicative effort that effectively creates differing requirements. There's been a lot of effort in the past to coordinate the GHG and CAFE regulations, and we want to see that continue in a way that lets manufacturers build a single fleet of vehicles that can comply with both regulations together, as an example. In coordination, we also want to see legislative actions coordinated. We need to see the regulators providing feedback from their technical experts to inform legislative efforts, so that the goals and the priorities are based on science, not just on politics. We also see the need to prioritize, excuse me, let me go back for a moment. There's also a need to coordinate supportive policies. We need supportive policies matched to the regulation and vice versa. For example, regulations driving EV sales past organic market demand will need supporting policies to increase that market demand. I mentioned earlier the need to develop both infrastructure and the vehicle market at the same time. People like to think about this as a chicken and egg paradigm, but neither really come first. They have to come together. The next potential guidepost I'd like to offer is prioritization. In terms of prioritization, we need the agencies to recognize there are limited resources to do it all. Designing and building vehicles takes massive amounts of human and monetary capital. There are only so many engineers that can be devoted to any one program, to any one engine, to any one battery set. And similarly, there's only so much money that can be provided to any one vehicle as it's being developed. So what we need to do is to balance consumer demands within the vehicles and investment across multiple vehicle lines as manufacturers. So key prioritization issues in the next decade will be, how do we balance ICE versus EV investments? I think we're all in agreement that we want to continue to improve ICE vehicles, and that we see this transition coming and want to participate and support a transformation to net zero emission vehicles. But we need to balance how that money is outlaid so that we have, reasonable regulations that can be met. Manufacturers are already noting that they are reducing or eliminating investments in ICE in favor of electrified vehicles. Finally, there's a need for flexibility. Gosh, I keep doing that, sorry. And this isn't necessarily terms of flexibility in terms of more credits and things of that nature. What I'm talking about is a need to recognize that transformational change is unlikely to happen without hiccups along the way. Many coordinating activities all have to happen together, and there's a lot of moving pieces that, unless we fit the puzzle pieces together at the same time, don't develop this comprehensive transformation that we're looking for. Thus, we need to have some flexibility to allow adjustments as needed to react to different conditions than are first expected. That can include ongoing assessments of market readiness and customer adoption, and the present focus on technology will become less relevant as we shift to EVs, and the enabling conditions and market forces will become more important to understand. Before I finish for the day, I'd like to take a moment to direct your attention to several resources that you may be interested in for more information that play into today's topics and the things that I've been talking about. First is our weekly market, Reading the Meter. Reading the Meter provides sales and production forecasts, recent trends in sales and production, sales, energy prices, vehicle transaction information, and news regarding economic recovery from the COVID-19 pandemic, among other topics. Next is our innovation agenda, where Auto Innovators lays out its vision for cleaner, safer, and smarter personal automotive transportation. And finally, specifically regarding federal government policy in EVs, you can find additional details in our EV policy letter to President Biden, all available at autosinnovate.org. And one final comment here that we do have our own webinar tomorrow called Charging Forward, Accelerating the Electric Vehicle Market in the US. That is a free to attend webinar, and you can register for that at our autosinnovate.org website also. So thank you for your time, and I'd like to open the floor for questions.
You in your presentation, you had some real nice slides that show the amount of money that the new administration is talking about providing. When you guys look at that amount and where it's being spent, are you seeing things matching what you think needs to be done at the right amounts, and are there some places where you think some more needs to be spent than what they're suggesting?
Yeah, that's a good question, Bruce. I think that we see all of this are positive steps in the right direction. I recognize there are a lot of political challenges, even obtaining the funding that's already being talked about. But there's clearly a need for more money to be spent in this area, and some of doesn't all have to come from the government. I think that there's going to be a large role, especially in this still relatively early market for electric vehicles and hydrogen fuel cell vehicles, in terms of encouraging those types of investments. But there's others that I think will start to become more interested in investing this as we go into the future. But I don't want to de-emphasize, that government funding is an important thing right now to at least kickstart this and start putting those pieces in place so that the market and consumers are confident, as Congresswoman Dingell was talking about, that infrastructure will be there to charge their vehicles, and that the vehicles aren't going to be so expensive that they're not affordable.
Very good, thank you. One of our attendees asked, to what degree are automakers willing to invest and take at least partial responsibility for some of the efforts in the, quote, comprehensive strategy, including consumer awareness and charging infrastructure?
Well, in terms of consumer awareness, automakers are already investing. A number of automakers have invested in the Northeast, and man, I'm struggling to bring the name of the program to mind immediately. Others are more involved with it than I am. Yeah. But there's been a coordinated effort, a partnership with the Northeast states to try to bring electric vehicle knowledge and experience more to the forefront, including a long-running advertising campaign over the last several years and ride and drive type events. In terms of infrastructure, I think each manufacturer will be making their own choices on how to invest in that. Certainly, some manufacturers have, for example, Tesla's, have already made some of their own investments in those areas, and other manufacturers, I'm sure, are looking at similar things. It really depends on where they see opportunities for their businesses as they move forward as more of mobility companies than traditional automakers, I think.
Now that kind of brings us back to the question that I asked a little earlier in the conference, that kind of focused on the role that manufacturers play in working with government to kind of deal with the issues of supply. Now, we've dealt with, and you mentioned it briefly in your talk as well, the supply base and how the supply base can support, needs to support what's going on here, and what kind of support does the supply base need? Now, we were talking about the globalization story, right? And do the manufacturers traditionally over the last 20 years have been global manufacturers and looking for the best price for their components, and wherever that might be. Now the story is now more focused on how do we bring some of that stuff back to the U.S. But that U.S. is not always the most profitable place to provide components. How do the manufacturers feel about this trend of trying to get components and supply back into the U.S.?
It's a toughie, Bruce. I'm really hesitant to put words in their mouth in that area. It's just not something that I've dealt with a whole lot with on the supply chain side. Certainly, right now, if we just use chips as an example, yeah. It's almost like a supply from wherever, but we need to invest in that. And these companies are building vehicles in the U.S. for the U.S. It doesn't matter what companies, I don't think there really is such a thing anymore as a Japanese versus a US versus a German auto manufacturer. We're all building vehicles in the United States, and investing in supply chains to support that production, I think, is important regardless of who you are, where the vehicles are.
Now, I see the challenge being if the U.S. supports the development, say, of chip makers in the U.S., will companies buy chips from them as opposed to buying them from Taiwan, where they might be cheaper? That becomes, the profit motive is strong. The purchasing departments have goals about, continuing cost reduction. And they saw globalization as their strategy to continue to bring costs down or control costs, right?
It's kind of like, isn't that the beautiful thing about how supply and demand works, though? I mean, if you can't build whatever the component is and try to charge something more than kind of the average, if you will. I mean, you have to have some unique feature that drives an extra cost. And if you're just building a commodity, then we have to somehow find ways to make these supply chains profitable in the U.S. at a price point that competes with outside of the U.S. type supplies. They're not going to be able to, you're not going to build a plant that's not going to be profitable because you can't sell it the price you need to sell it at, in other words.
Right, and it's traditionally it's all been up to the market, but now you have actually the government saying, this is making your lives more difficult, and maybe we should be investing, and maybe we should be helping you and make investments, making companies make investments to do that stuff in the U.S. And we know that traditionally, this is, if anything is related to the Defense Department, it usually is very supported. And
yeah, so what I find interesting too is why is it less expensive to build it outside? And I think Congresswoman Dingell touched on these things a little bit, right? Less environmental regulation in places, or less recognition or respect for labor, things of that nature outside of the U.S. And although we haven't really gotten here in the U.S., I mean, there's a lot of talk politically about, if there's going to be things like taxing carbon, and I'm not trying to draw a position on that at this moment, right. But if there is going to be something of that nature, or pollution regulations, how do you limit leakage outside of the United States? Are there cross-border adjustments, things of that nature? And not having any particular expertise in this area, that's kind of where my head goes to try and answer your question, is that there's going to be, in the future, as we try to grapple with some of these issues, how do you make those adjustments and recognize that this is why they're less expensive? Now let's make sure that the U.S. stays competitive, and put everybody on equal footing.
We got lots of other questions for you, but we're out of time. I wanted to thank you, Michael, for your presentation. You really some very good insights, I think, from a manufacturer perspective about what they see going on with the new administration and the new role of government in the auto industry. Our next conference is July 14th, our 13th annual Powertrain Strategies for the 21st Century Conference. Meet the speakers. People can still sign up for that if you would like. And the presentations from this conference should be up on our website, and we'll be sending out the link to those to everybody who registered for the conference, and we'll send those out this weekend. If you have any other questions, feel free to email me at bbl@umich.edu. Thank you all. Thank you to all our speakers, and thank you for all our attendees, and we'll see you next time. Take care.